What if everything we've been taught about human history is fundamentally wrong? What if the timeline we've accepted, that complex civilizations only emerged within the last few thousand years, is missing entire chapters of human achievement? What if an advanced society once flourished on Earth, mastered technologies we can barely imagine, and then disappeared so completely that we're only now beginning to question whether they ever existed at all? Before we dive into this mind-bending exploration tonight, I'd love to know, where in the world are you watching from? Drop a comment below and let me know what time it is where you are right now. There's something beautiful about the fact that while we're questioning the very foundations of human history together, we're all sharing this moment from different corners of our planet. If this kind of deep contemplative journey resonates with you, please consider subscribing to Simply About Earth. Since we're building a community of curious minds, your subscription really helps share these explorations with others who find wonder in the biggest questions we can ask about our world. Now, imagine stepping into a time machine and traveling back 100,000 years. You expect to find primitive humans huddled around fires struggling to survive with crude stone tools. But instead, you discover something impossible: advanced cities stretching beyond the horizon, technologies that seem to bend the laws of physics, a sophisticated society that makes our modern world look like we're still playing in the sandbox. And then you realize the most disturbing truth of all: they're gone, completely erased. Nothing left but whispers in the wind and mysteries buried so deep that we've convinced ourselves they never existed. Hello, and welcome to Simply About Earth, where quiet curiosity meets the profound mysteries of our planet, and wonder is allowed to take its time. Tonight, we're going to embark on a journey that challenges everything you think you know about human history. A journey that might just change how you see our species, our planet, and our place in the cosmic story. We live in a world where history feels like a straight line. Open any textbook, and the story unfolds predictably. Simple hunters and gatherers slowly progressing through villages and kingdoms, culminating in the modern nations we know today. It all makes perfect sense on paper, a neat timeline suggesting that human civilization only began a few thousand years ago. But sometimes the neatest stories are the most misleading. Here's what most people never think to consider: that timeline isn't based on knowing everything that has ever happened. It's based on what little evidence we've found, and how far back that evidence currently reaches. We've built our entire understanding of the past on fragments, pieces of pottery, stone tools, and architectural remains that happened to survive long enough for us to discover them. But what about everything that didn't survive? Think about this carefully. If our own civilization ended tomorrow, and 100,000 years passed before anyone came looking for us, what would actually remain? Our skyscrapers would crumble to dust. Our roads would be reclaimed by forests. Our computers would rust into unrecognizable fragments. Even our most durable monuments, the pyramids, Mount Rushmore, the Great Wall, would be worn away by wind, rain, and the relentless passage of time. In that vast span of time, whole continents change shape. Oceans rise and fall like breathing giants. Ice ages come and go like slow bulldozers, grinding everything beneath them into scattered debris. Forests grow over cities. Earthquakes reshape the landscape entirely. Plate tectonics drag entire regions down into the Earth's mantle, permanently erasing whatever once stood there. Metal rusts. Concrete crumbles. Plastic breaks down under decades of sunlight. Without constant maintenance, everything we've built would simply disappear. So when archaeologists tell us there's no evidence for an advanced society 100,000 years ago, that doesn't necessarily mean it didn't exist. It might mean the evidence is gone, hidden in places we haven't thought to look, or buried so deeply beneath layers of time that we'll never find it. And here's the truly unsettling part. This isn't just speculation anymore. In 2018, scientists at NASA and the University of Rochester published a groundbreaking paper exploring what they called the Silurian hypothesis, named after a reptilian species from Doctor Who. But their question was entirely serious. If an industrial civilization had existed on Earth millions of years before humans evolved, how would we detect it today? Their conclusion was startling. We probably wouldn't find cities or machines or any of the physical artifacts we typically associate with advanced societies, but we might find something else entirely. Chemical signatures embedded in the geological record, unusual isotope patterns, unexpected spikes in greenhouse gases, synthetic compounds that don't occur naturally. In other words, the fingerprints of a lost civilization might be written in the very rocks beneath our feet, and we're only just beginning to learn how to read them. But let's step back even further. Let's consider what the world was actually like 100,000 years ago, because the picture might surprise you. This was during the last ice age, when vast glaciers covered much of North America, northern Europe, and parts of Asia. But it wasn't a uniformly frozen wasteland. Tropical regions still enjoyed warm climates. Grasslands stretched across areas that are now forests or farmland, and most importantly, the sea levels were more than 100 meters lower than they are today, because so much water was locked up in those massive ice sheets. This exposed enormous coastal plains that are now completely underwater. What we call the English Channel was dry land connecting Britain to mainland Europe. Beringia, a vast bridge between Siberia and Alaska, linked Asia and the Americas. These weren't narrow strips of land, but huge continental shelves that could have supported large populations. And humans were already there. Anatomically modern Homo sapiens had existed for at least 200,000 years by this point. They had brains just as large and complex as ours. They were capable of abstract thought, symbolic communication, and sophisticated problem-solving. They made tools, used fire, and had languages complex enough to share detailed information across generations. But here's where our understanding gets both interesting and troubling. Our entire picture of these people, as primitive, comes from the artifacts we've found. Stone tools, bone fragments, and cave paintings. These are the materials that survived tens of thousands of years. But what if they had also developed technologies using materials that decompose completely? What if they built with advanced composites based on plant fibers? What if their tools were made from organic compounds that left no trace after centuries of decay? We might be dramatically underestimating what they knew simply because the evidence has vanished without a trace. Now, I want you to imagine something. Picture a small group of highly intelligent people living in one of those fertile coastal regions that no longer exists. Maybe they discovered principles of engineering, mathematics, or energy that we haven't rediscovered yet. Maybe they developed sustainable technologies that worked in harmony with their environment rather than trying to dominate it. Maybe they built cities from materials that were designed to decompose cleanly when they were no longer needed. Such a civilization could have been incredibly advanced while leaving almost no archaeological footprint. No massive stone monuments, no metal frameworks, no permanent scars on the landscape. Just knowledge passed down through generations, until something happened to break the chain. And what could have ended such a society? The possibilities are sobering. Climate change during the transition between ice ages could have dramatically altered their environment. A massive volcanic eruption, like the Toba supervolcano that erupted 74,000 years ago, could have plunged the world into years of darkness and famine. An asteroid impact could have triggered global catastrophe. Disease could have swept through their populations like wildfire. Or they might have simply made the kinds of mistakes that civilizations sometimes make, depleting their resources, fragmenting into conflicts that destroyed everything they had built, or developing technologies that ultimately turned against them. Any of these scenarios could have reduced a sophisticated society to scattered survivors, forced to rebuild from almost nothing, and over the following millennia, as new populations grew and spread across the earth, the memory of what came before could have faded into myth, then legend, then nothing at all. This brings us to one of the most intriguing aspects of this possibility: the role of genetics. If such a civilization existed, and if its people were human or closely related to humans, then part of their legacy might still survive in our own DNA. We already know that modern populations carry genetic fragments from encounters with Neanderthals and Denisovans. If there were other advanced human groups from even earlier periods, their genes could still be scattered throughout our genome, invisible markers of a forgotten past. Studies of ancient DNA have revealed surprising complexity in human migration and interbreeding patterns. Each new discovery pushes back the timeline of human sophistication and suggests that our ancestors were far more capable than we previously imagined. But genetics can tell us that different groups met and mixed. It can't reveal whether those groups had cities, technologies, or knowledge systems that we would recognize as advanced. We could be carrying the biological legacy of a lost civilization without ever knowing it. This possibility forces us to reconsider some of our most basic assumptions about progress and permanence. We like to think of human advancement as a straight line upward, with each generation building on the achievements of the last. But history shows us that knowledge can be lost as easily as it's gained. Civilizations rise and fall, libraries burn, skills are forgotten, entire cultures can disappear, leaving behind only fragments for future archaeologists to puzzle over. If it can happen to us within the span of recorded history, imagine what could be lost over 100,000 years. And this is where the story becomes not just about the past, but about the future. Because if we accept the possibility that advanced societies have risen and fallen before, we have to ask ourselves some uncomfortable questions. Are we unique? Are we the first to reach this level of technological sophistication? And if we're not, what happened to those who came before us? Most importantly, are we destined to follow the same path? The evidence we would expect to find from such a civilization might not be cities and monuments. It might be subtle chemical anomalies in deep geological layers, unusual isotope ratios that hint at large-scale industrial processes, concentrations of rare elements that don't occur naturally in such quantities. The fingerprints of an advanced society written in the language of chemistry and physics rather than architecture and art. But here's the problem. We're not systematically looking for such evidence. Archaeology focuses most of its resources on sites and time periods where discoveries are already expected. Nobody is drilling deep under the ocean floor or through kilometers of ice searching for traces of civilizations from 100,000 years ago, because mainstream science doesn't consider it likely. In science, expectations shape the search, and the search shapes what we find. If we don't expect to discover something, we probably won't recognize the clues even if they're right in front of us. This brings us to perhaps the most sobering realization of all. The problem of time itself, 100,000 years, is an almost incomprehensible span of time. It's longer than all of recorded human history multiplied by 20. It's enough time for ice ages to come and go, for continents to shift, for entire species to evolve and go extinct. In that vast stretch of time, almost nothing made by intelligent hands can survive in recognizable form. Even if a civilization had built cities to rival our own, even if they had developed technologies we can barely imagine, the slow work of erosion, decay, and geological change would erase almost every trace. But not necessarily every trace. And that's what makes this question so compelling. Somewhere in the deep layers of rock, in the chemical composition of ancient ice, in the genetic patterns of modern humans, there might be whispers of a story we've never heard, evidence of intelligence and achievement from a time so distant that we've forgotten it was even possible. If you're finding this exploration as fascinating as I am, please take a moment to hit that like button. It really helps the algorithm share this content with other curious minds who might be wondering about the same profound questions. As we continue our journey tonight, I want you to consider something that might fundamentally change how you think about archaeological evidence. We've been taught to trust what we can dig up, to base our understanding of the past on physical artifacts that have survived long enough for us to find them. But what if that approach is like trying to understand a library by examining only the books that survived a fire? When archaeologists tell us that there's no evidence for complex societies beyond a certain date, they're being accurate about what they've found, but they're also working within constraints that become more severe the further back in time we go. And when we're talking about 100,000 years, those constraints become almost absolute. Let me walk you through exactly why the absence of evidence from such deep time might tell us more about the limitations of preservation than about what actually happened. Material decay operates on timescales that are difficult for us to grasp intuitively. We're used to thinking of stone as permanent, but even the hardest granite slowly dissolves under constant exposure to rain. Iron, which forms the backbone of our modern world, rusts into powder when exposed to oxygen and moisture. Aluminum corrodes. Copper turns to green dust. Even gold, which we consider nearly indestructible, can be scattered and lost through erosion and geological processes. But let's consider something even more fundamental: the bias in what survives. Throughout human history, the most durable materials have also been the crudest. Stone tools outlast wooden handles. Pottery fragments survive while textiles vanish. Bone remains while leather disappears. This means that our archaeological record is heavily skewed toward the simplest, most primitive-looking aspects of any culture. Imagine if future archaeologists tried to understand our civilization based only on what might survive 100,000 years from now. They would find fragments of concrete, some corroded metal, and perhaps pieces of the most durable plastics. From these remains, they might conclude that we were a primitive society that built crude shelters and made simple tools. They would have no idea about our electronics, our books, our art, our music, or the sophisticated knowledge systems that define our culture. Now multiply that preservation bias by the immense span of time we're considering. 100,000 years ago takes us back to a period when the very surface of the Earth was dramatically different from what we see today. During the last ice age, massive glaciers covered vast portions of the northern continents. These weren't just larger versions of the glaciers we see in places like Alaska or Greenland today. They were ice sheets kilometers thick, so heavy that they actually depressed the Earth's crust beneath them. When these glaciers moved, they acted like enormous bulldozers, scraping away everything in their path and grinding it into fragments scattered across hundreds of kilometers. When the Ice Age ended and the climate warmed, these glaciers melted, releasing unimaginable quantities of water. Rivers became torrents capable of carving out entire valleys in a matter of decades. Flash floods larger than anything in recorded history swept across continents, washing away anything that hadn't been buried or destroyed by the advancing ice. But perhaps the most dramatic change was in sea level. With so much water locked up in ice, the oceans were more than 100 meters lower than they are today. This exposed vast continental shelves that had been underwater for millions of years. Entire subcontinents became available for habitation, offering rich coastal plains, river valleys, and fertile lands. And here's the critical point: these newly exposed lands would have been the most attractive places for any intelligent species to settle. They offered access to both marine and terrestrial resources. They had moderate climates, freshwater sources, and natural harbors. If an advanced civilization had existed during this period, logic suggests they would have built their cities and centers of learning in exactly these locations. When the ice melted and sea levels rose, all of these areas were flooded, not gradually, but sometimes catastrophically fast. Entire landscapes disappeared beneath the waves, along with anything that had been built on them. And unlike land-based archaeological sites, which can sometimes be preserved under layers of sediment, these drowned regions were often scoured by currents, waves, and storms before being buried under marine deposits. Today, these submerged continental shelves represent some of the largest unexplored areas on our planet. We know more about the surface of Mars than we do about many of these underwater regions. The few underwater archaeological investigations that have been conducted have already revealed fascinating glimpses of human settlements from much more recent periods, but we've barely scratched the surface of what might be down there. Consider the scale of what was lost. Conservative estimates suggest that more than 20 million square kilometers of habitable land disappeared beneath the oceans at the end of the last ice age. That's an area roughly the size of North America. Most of it has never been systematically mapped, let alone archaeologically investigated. And this brings us to a crucial point about the nature of archaeological investigation itself. Archaeology is not a neutral process of discovery. It's shaped by expectations, funding priorities, and practical limitations. Most archaeological resources are directed towards sites and time periods where significant finds are already expected. There's little incentive to fund expensive deep-sea expeditions looking for evidence of civilizations that mainstream academia doesn't believe existed. Even on land, excavating to depths that might contain artifacts from 100,000 years ago is extraordinarily challenging. In most regions, you would need to dig through dozens of meters of accumulated sediment, dealing with groundwater, unstable soil conditions, and the enormous cost of moving that much material. Without strong evidence that something important lies beneath, such excavations are rarely attempted. This creates a circular problem. We don't look for evidence because we don't expect to find it, and we don't expect to find it because we haven't looked. Meanwhile, time continues its relentless work of erasure, making any remaining traces even more difficult to detect. But geological forces don't just hide evidence, they actively destroy it. Plate tectonics, the slow movement of the Earth's crustal plates, operates on timescales that make 100,000 years seem almost recent. In that time, some regions are uplifted into mountains while others are dragged down into the mantle and melted. Volcanic activity can bury entire regions under layers of ash and lava. Earthquakes can shatter and scatter anything made by intelligent hands. Even erosion, which seems like such a gentle process on human timescales, becomes an irresistible force when given enough time. Water finds its way into the smallest cracks, freezes and expands, breaking apart even the hardest stone. Wind carries abrasive particles that slowly grind down anything exposed to them. Rivers change course, carving new channels and abandoning old ones, washing away anything in their path. Consider what this means for the survival of artificial structures. Even if an ancient civilization had built monuments to rival our greatest achievements, even if they had constructed cities of stone and metal, the combined forces of geology would reduce them to scattered fragments within a few millennia. After 100,000 years, even the largest buildings would be indistinguishable from natural rock formations. But there's another layer to this problem that we haven't yet considered: the possibility that an ancient advanced civilization might not have built in ways we would recognize at all. Our model of advancement is based on our own experience. We assume that sophisticated societies must leave behind durable monuments, metal tools, and permanent structures. But what if that assumption is wrong? What if a truly advanced civilization had learned to live in harmony with their environment rather than trying to dominate it? Imagine a society that built using materials designed to biodegrade completely when no longer needed. Their architecture might have been based on advanced organic composites, stronger and more versatile than anything we have today, but engineered to return harmlessly to the soil after a predetermined period. Their tools might have been grown rather than manufactured, using principles of bioengineering that we're only beginning to rediscover. Such a civilization could have been far more sophisticated than our own, while leaving virtually no archaeological trace. They might have viewed permanent monuments as wasteful or even immoral, preferring to invest their knowledge and energy in sustainable systems that enhanced rather than scarred the landscape. Their transportation networks might have been biological rather than mechanical. Instead of building roads, they might have engineered ecosystems that facilitated movement and communication. Instead of metal vehicles, they might have used living systems capable of self-repair and adaptation. Even their energy systems could have been radically different from ours. While we burn fossil fuels and split atoms, leaving distinctive chemical signatures in the environment, they might have developed clean technologies that tapped into natural energy flows without disrupting them. Geothermal systems that left no surface trace, biological solar collectors that appeared indistinguishable from ordinary forests, tidal generators that worked in perfect harmony with ocean currents. If such a civilization had existed, our current archaeological methods would be completely inadequate to detect it. We're trained to look for stone tools, metal objects, and permanent structures. We wouldn't recognize advanced biotechnology even if we found it, because our expectations are shaped by our own technological path. This possibility becomes even more intriguing when we consider the time periods involved. 100,000 years is not just ancient in human terms, it's long enough for multiple ice ages to come and go. It's long enough for dramatic climate changes, for the evolution and extinction of entire species, for the rise and fall of multiple civilizations. And this brings us to perhaps the most unsettling possibility of all, that we might not be looking at the remains of just one lost civilization, but of a cycle of rise and fall that has repeated many times throughout Earth's history. Archaeological evidence suggests that human intelligence and creativity have remained essentially constant for at least 200,000 years. Anatomically modern humans from that period had brains identical to ours in size and structure. They were capable of the same kinds of abstract thinking, problem solving, and cultural transmission that characterize our species today. Yet for most of that time we assume they lived in small nomadic groups with simple technologies. But what if that assumption is based on incomplete evidence? What if the archaeological record is missing entire chapters of human achievement because those achievements were either deliberately temporary or have been erased by time? Consider how quickly knowledge can be lost even in our modern world. Within a single generation, traditional skills and technologies can disappear if they're not actively maintained and transmitted. Ancient languages vanish when their last speakers die. Traditional ecological knowledge accumulated over centuries can be lost in a single catastrophic event. Now imagine what could happen over hundreds of generations. Even if some members of an advanced civilization survived whatever catastrophe ended their society, the specialized knowledge required to maintain their technologies could easily be lost. Within a few centuries, their descendants might be living very differently, with only fragments of stories and half-remembered techniques to remind them of what their ancestors had achieved. This process of cultural collapse and recovery might have happened multiple times throughout human history. Each time, a civilization might have developed sophisticated technologies and knowledge systems, only to lose them when faced with climate change, natural disasters, disease, or conflict. The survivors would start over, slowly rebuilding their societies, perhaps eventually reaching the same heights again, only to face the same risks of collapse. If this cycle has repeated throughout our species' existence, then the scattered legends of golden ages and lost civilizations that appear in cultures around the world might not be pure mythology. They might be distorted cultural memories of real achievements that were lost so long ago that they've been transformed into stories of gods and magic. And this brings us to one of the most fascinating aspects of this entire question. We've been assuming that any traces would have to be physical artifacts, but what if the most durable evidence is actually biological? DNA is remarkably stable compared to stone or metal. Under the right conditions, genetic material can survive for hundreds of thousands of years. And if ancient human populations had developed advanced knowledge of genetics and bioengineering, they might have left traces of their work in the genomes of living organisms. Recent advances in genetic archaeology have revealed surprising complexity in human migration and breeding patterns. We've discovered that modern humans carry DNA from multiple archaic human species, including some that we've only just identified. Each new genetic study pushes back the timeline of human sophistication and reveals that our ancestors were far more capable and far-ranging than we previously imagined. But genetics can tell us that different populations met and interacted. It can't directly reveal whether those populations had cities, technologies, or knowledge systems that we would recognize as advanced. A genetic signature of an unknown human group from 100,000 years ago would be fascinating, but it wouldn't prove that they were the inheritors of a lost civilization. However, it might prompt us to ask new questions and look in new places. And that's perhaps the most important point of all. Our ability to find evidence of ancient civilizations depends not just on whether such evidence exists, but on whether we're asking the right questions and looking in the right places. Now we come to the heart of what makes this question more than just speculation, because while the idea of a lost civilization might sound like science fiction, it has actually been seriously considered by some of the world's leading researchers, and their conclusions might surprise you. In 2018, Dr. Gavin Schmidt from NASA's Goddard Institute for Space Studies and Dr. Adam Frank from the University of Rochester published a paper that asked a startling question: if an industrial civilization had existed on Earth millions of years before humans evolved, how would we detect it today? They called it the Silurian hypothesis, a playful reference to the reptilian species from the British science fiction series Doctor Who. But behind the humorous name lay a profound scientific inquiry that challenged everything we think we know about how civilizations leave their mark on a planet. Schmidt and Frank weren't claiming that such a civilization had definitely existed. They were asking a more fundamental question: what would we actually expect to find if it had? And their answer was both illuminating and disturbing. Physical artifacts, they concluded, would be essentially hopeless to find. Buildings, machines, infrastructure, even the bones of the beings who built them would all have been ground to dust by geological processes operating over millions of years. But there might be something else, something far more subtle, yet potentially much more durable: chemical signatures embedded in the geological record. Every civilization that develops industry and large-scale energy production leaves fingerprints in the environment. We're leaving them right now. Our use of fossil fuels is dramatically altering the composition of the atmosphere, increasing concentrations of carbon dioxide, methane, and other greenhouse gases. Our industrial processes are creating synthetic chemicals that never existed in nature. Our nuclear activities are producing radioactive isotopes with distinctive signatures. Most importantly for our question tonight, these chemical changes don't just affect the present, they get locked into ice cores, ocean sediments, and rock layers, creating a permanent record that can persist for millions of years. Even if every physical trace of our civilization were erased, these chemical fingerprints would remain, waiting for some future geologist to discover and interpret them. Schmidt and Frank realized that this principle works in reverse. If we wanted to detect an ancient industrial civilization, we shouldn't be looking for cities or machines. We should be looking for unusual chemical anomalies in the geological record from their time period. But here's where the story becomes even more intriguing. When they began examining what such anomalies might look like, they discovered something unexpected. We haven't been systematically searching for them. The geological record from periods relevant to our question, tens of thousands to hundreds of thousands of years ago, simply hasn't been studied with this possibility in mind. This raises a profound question about the nature of scientific discovery itself. In science, we tend to find what we're looking for. If researchers aren't specifically searching for signs of ancient industrial activity, they're unlikely to recognize such signs even if they encounter them. Unusual chemical ratios might be dismissed as natural variations. Unexpected isotope concentrations might be attributed to unknown geological processes. Synthetic compounds might be assumed to have natural origins we simply haven't identified yet. Consider what kinds of chemical signatures an advanced civilization might leave behind. If they had large-scale metallurgy, we might find unusual concentrations of rare metals in sediment layers from their period. If they used nuclear technology, we might detect artificial isotopes that don't occur naturally. If they had extensive agriculture or forestry, we might see dramatic changes in pollen records or carbon ratios that indicate massive land use changes. Perhaps most intriguingly, if they had developed industrial processes we haven't yet discovered, they might have left chemical signatures that we would find completely baffling: synthetic compounds with no known natural origin, isotope ratios that don't match any geological process we understand, elemental concentrations that seem to violate our understanding of how these materials distribute naturally. And here's the truly unsettling part. Such anomalies might already have been found and dismissed or misinterpreted. Scientific literature is filled with reports of unusual chemical findings that don't quite fit established models, unexpected isotope ratios in ice cores, anomalous metal concentrations in sediment layers, organic compounds that seem out of place in their geological context. Most of these are eventually explained by natural processes we didn't initially consider, but some remain mysteries. What if some of these unexplained anomalies are actually evidence of exactly what we're discussing tonight? What if the chemical fingerprints of an ancient civilization are already sitting in research databases, waiting for someone to recognize them for what they might be? This possibility becomes even more compelling when we consider the specific time period we're investigating. 100,000 years ago isn't just ancient. It's a period that sits right at the edge of our current analytical capabilities. It's old enough that most physical evidence would have been destroyed, but recent enough that chemical signatures might still be detectable in the right circumstances. Ice cores from Greenland and Antarctica can preserve atmospheric information going back several 100,000 years. Ocean sediment cores can capture chemical changes over similar timescales. Cave formations and lake deposits can lock in environmental data from periods spanning hundreds of millennia. The raw data needed to detect an ancient civilization's chemical fingerprints might already exist. We might just need to know how to look at it differently. But detecting such signatures requires overcoming several significant challenges. First, we need to distinguish between natural chemical variations and those that might indicate artificial activity. Natural processes can create surprisingly complex chemical patterns, and separating artificial signals from natural noise is extraordinarily difficult. Second, we need to account for how chemical signatures change over time. Elements migrate through rock and sediment. Isotopes decay. Chemical compounds break down and recombine. What starts as a clear artificial signature might become increasingly ambiguous as tens of thousands of years pass. Third, we need to consider that an ancient civilization might have used chemical processes completely different from our own. We're looking for the kinds of signatures our industrial civilization produces, but a society with different technologies might have left entirely different fingerprints. Despite these challenges, there are some specific things we might look for. Unusual spikes in greenhouse gas concentrations that don't correlate with known natural events. Abnormal isotope ratios of elements commonly used in industry. Concentrations of rare earth elements that exceed what we would expect from natural processes. Synthetic organic compounds that have no known biological origin. Perhaps most promisingly, we might look for what researchers call technofossils, synthetic materials that could survive for geological timescales. While most human-made materials decompose relatively quickly, some artificial compounds are remarkably stable. Certain plastics, synthetic crystals, and engineered ceramics could potentially survive for hundreds of thousands of years under the right conditions. If an ancient civilization had developed similar long-lasting materials, traces of them might still exist in the geological record. They might appear as mysterious inclusions in rock layers, unexplained crystalline structures, or synthetic compounds that don't match any known natural process. And then there are the possibilities we haven't even considered yet. What if an ancient civilization had developed technologies based on principles we haven't discovered? What if they had mastered forms of energy production, materials science, or environmental engineering that leave fingerprints we wouldn't recognize because we don't yet understand the underlying processes? This brings us to one of the most intriguing aspects of the entire question: the possibility that evidence of ancient civilizations might be hiding in plain sight, misinterpreted as natural phenomena because we lack the conceptual framework to recognize artificial origins. Consider, for example, some of the geological mysteries that have puzzled scientists for decades. Unusual mineral formations that don't quite fit standard geological models. Unexpected elemental distributions that seem to require unknown natural processes. Strange crystalline structures that appear in rocks from specific time periods. Most of these anomalies eventually receive natural explanations as our understanding of geological processes improves, But what if some of them represent something else entirely? What if they're the remnants of artificial processes we simply don't recognize as artificial because they're so different from our own technologies? This possibility becomes particularly compelling when we consider that any civilization advanced enough to avoid leaving obvious physical artifacts might also have been advanced enough to develop technologies we haven't yet imagined. Their materials science might have been based on principles we're only beginning to discover. Their energy systems might have operated through mechanisms we haven't yet understood. Their manufacturing processes might have produced compounds and structures that we would find completely baffling. If such technologies had existed, their remains might look like natural phenomena to us simply because we lack the knowledge to recognize them as artificial. A synthetic crystal, designed to last for geological ages, might be classified as an unusual natural formation. An engineered biotechnology system might be mistaken for a strange evolutionary adaptation. The waste products of an unknown industrial process might be dismissed as the result of peculiar chemical reactions. But chemical signatures aren't the only potential evidence we might consider. There's also the possibility of what we might call landscape archaeology, the idea that some artificial modifications to the environment might be detectable even after vast periods of time. Large-scale mining operations, for example, create distinctive patterns in the geological record. If an ancient civilization had extracted significant quantities of metals or other materials from the earth, the scars of that extraction might still be visible to geologists who know what to look for. Ancient quarries, even if filled in and overgrown, can sometimes be detected through subtle variations in rock layers and soil composition. Similarly, large-scale construction projects can leave traces that persist for enormous periods. The foundations of massive buildings, even if the buildings themselves have completely disappeared, can create detectable anomalies in ground-penetrating radar surveys. Ancient road networks buried under meters of accumulated sediment sometimes show up in satellite imagery as slight variations in vegetation patterns. But perhaps most intriguingly, there's the possibility that some artificial landscapes might have been designed to be so harmonious with natural systems that they would be virtually undetectable even to trained observers. A civilization with sufficiently advanced ecological knowledge might have created modified environments that functioned better than unmodified nature while appearing completely natural to future investigators. Such cryptic engineering might represent the ultimate expression of technological sophistication, the ability to improve natural systems so subtly that the improvements are invisible to anyone who doesn't understand the underlying principles. An ancient civilization might have left behind entire ecosystems that are actually carefully designed and maintained artificial systems, but which we interpret as pristine nature because we can't detect the engineering. This possibility forces us to question some of our most basic assumptions about what constitutes evidence of intelligence and technology. We tend to look for things that are obviously artificial, clearly different from natural patterns. But a truly advanced civilization might have moved beyond such crude approaches, developing technologies that work with natural systems rather than against them. If such technologies had existed, their traces might be everywhere around us, hidden in plain sight. The forest that seems unusually healthy and diverse might actually be a carefully designed ecosystem. The river that flows in a particularly efficient pattern might be following an artificially modified course. The mineral deposits that seem too convenient to be natural might actually be the result of ancient geological engineering. And this brings us to perhaps the most unsettling possibility of all, that we might be living in a world that still bears the subtle marks of ancient intelligence, but we lack the knowledge to recognize those marks for what they are. The more we explore this question, the more we realize how much we don't know about our own planet's deep history. The further back in time we try to look, the more gaps and uncertainties we encounter. And those gaps aren't just missing data, they're missing entire categories of possibility that we haven't learned to consider. Tonight, we've explored how chemical signatures might preserve evidence of ancient civilizations long after all physical traces have vanished. We've considered how our expectations and methods might blind us to evidence that doesn't match our technological paradigms. And we've begun to glimpse the possibility that the natural world itself might contain hidden records of intelligence and engineering from times so ancient that we've forgotten they were possible. But this is still only the beginning of our investigation. There are other types of evidence to consider, other ways that traces of an ancient civilization might have survived the vast span of time that separates us from them. As we venture deeper into this possibility tonight, we encounter what might be the most promising and yet most challenging frontier in our search for evidence, the vast underwater realms that were once dry land. Because if an advanced civilization existed 100,000 years ago, there's a very good chance that much of their world now lies beneath the waves, hidden in places we've barely begun to explore. Picture this scenario for a moment. During the height of the last ice age, when enormous glaciers locked up tremendous quantities of water, the ocean levels were more than 100 meters lower than they are today. This exposed continental shelves that are now completely submerged, creating millions of square kilometers of additional habitable land. These weren't narrow strips of beach or marginal coastal areas. They were vast plains, river valleys, and coastal lowlands that would have offered some of the most attractive living conditions on the planet. Rich soils deposited by rivers over millions of years, access to both marine and terrestrial resources, natural harbors and transportation routes, moderate climates protected from the harsh extremes of the glaciated interior. If you were an intelligent species looking for the ideal place to build a civilization, they offered everything a growing society would need: fertile land, abundant food sources, fresh water, natural resources, and geographic advantages that would facilitate trade and communication. And then, as the climate warmed and the ice sheets melted, all of these ideal locations slowly disappeared beneath rising seas, not gradually over millions of years, but relatively rapidly in geological terms. Over just a few thousand years, entire landscapes that might have supported large populations and sophisticated cultures were swallowed by the ocean, along with everything that had been built on them. Today, these drowned lands represent some of the largest unexplored territories on our planet. We have better maps of the surface of Mars than we do of most underwater continental shelves. The few systematic surveys that have been conducted have already revealed tantalizing glimpses of what might be down there: ancient river channels, submerged terraces that might once have been settlement sites, and geological formations that suggest the presence of freshwater sources that could have supported large populations. But underwater archaeology faces enormous challenges that make systematic exploration extraordinarily difficult. The equipment required is expensive and technically complex. Working underwater limits the time and precision available for excavation. Ocean currents, marine growth, and sediment accumulation can obscure or destroy evidence. And unlike land-based archaeology, where local knowledge and surface features can guide investigations, underwater sites must be located through expensive sonar surveys and remote sensing technologies. Perhaps most importantly, the very idea of searching for evidence of advanced civilizations in these underwater regions falls outside the mainstream expectations of archaeological research. Funding agencies and research institutions are more likely to support investigations that have a reasonable chance of confirming established historical timelines, rather than projects that might revolutionize our understanding of the past. This creates a situation where some of the most promising locations for finding evidence of ancient civilizations are also the least likely to be systematically investigated. We might be sitting on top of one of the greatest archaeological discoveries in human history, but we lack the resources, the technology, and perhaps most importantly, the expectation that would drive us to look for it. Yet the few underwater discoveries that have been made paint a tantalizing picture of what might be waiting. Off the coast of India, marine archaeologists have found submerged structures that appear to be artificial and are far older than expected. Near Japan, underwater formations have sparked debates about whether they represent natural geological processes or ancient human construction. In the Mediterranean, Entire ports and settlements from historical periods have been discovered beneath the waves, preserved in ways that would have been impossible on land. These discoveries from relatively recent periods hint at what might be preserved from much earlier times. If stone structures from a few thousand years ago can survive underwater, what might remain from tens of thousands of years ago? The preservation conditions in some underwater environments are actually superior to those on land, particularly in areas where sediment accumulation is rapid enough to bury and protect artifacts, but gentle enough not to destroy them. But underwater preservation comes with its own complications. Marine organisms can colonize and gradually dissolve artificial structures. Chemical reactions in seawater can alter the composition of buried materials. And the dynamic nature of underwater environments means that sites can be exposed, buried, and exposed again multiple times as sediment patterns shift. This brings us to another fascinating dimension of our investigation: the possibility that evidence of ancient civilizations might be preserved not just in physical form, but in the collective memory of human cultures themselves. Oral traditions represent one of the most durable forms of information storage our species has developed. Stories, songs, and cultural memories can be passed down through hundreds of generations, preserving information about events that happened long before written records began. And when we examine oral traditions from around the world, we find some remarkably consistent themes that might be more than just mythology. Flood stories appear in cultures across every continent, often with strikingly similar details about great waters that destroyed previous civilizations. While many of these stories are usually interpreted as religious allegories or explanations for natural disasters, some researchers have begun to wonder if they might represent cultural memories of real events. In Australia, Aboriginal oral traditions described coastal lands that were once dry but were swallowed by rising seas. When researchers investigated these stories, they found that some of them accurately describe geographical features that were submerged more than 7,000 years ago, suggesting that reliable information can indeed be preserved in oral form for remarkable periods of time. If cultural memory can preserve accurate information for 7,000 years, what about longer periods? Could some of the world's most persistent mythological themes actually be distorted memories of real events from much earlier periods? Consider the widespread legends of golden ages, times when humanity possessed great knowledge and lived in harmony with nature, only to lose these abilities through some catastrophe or moral failing. These stories appear independently in cultures that had no historical contact with each other, suggesting either that they represent universal human psychological patterns or that they preserve memories of actual historical periods. Similarly, many cultures have traditions about lost lands, sunken cities, and vanished peoples who possess technologies or knowledge that subsequent generations could not match. While these stories are often embellished with supernatural elements, their core themes of technological loss and geographical change might reflect real events. But oral traditions face the same interpretive challenges as any other form of evidence. Stories change over time as they're retold. Details are added, removed, or altered to fit the cultural context of each new generation. Symbolic and metaphorical elements become mixed with factual information, and the supernatural tends to replace the technological as cultures lose the knowledge needed to understand their own past. This means that even if oral traditions do preserve memories of advanced ancient civilizations, those memories would be heavily disguised by thousands of years of retelling and reinterpretation. We might be surrounded by cultural evidence of forgotten technological achievements, but we lack the key to separate the historical core from the mythological overlay. However, there's another category of potential evidence that deserves serious consideration: the controversial realm of out-of-place artifacts. These are objects that appear to be artificial but are found in geological or archaeological contexts where they shouldn't logically exist according to our current understanding of technological development. Most out-of-place artifacts turn out to have conventional explanations once they're properly studied. They may be natural formations that superficially resemble artificial objects, recent items that became accidentally associated with older materials, or genuine artifacts that have been misdated due to contamination or misunderstanding of their geological context. But a few cases remain genuinely puzzling. The Antikythera mechanism, discovered in a shipwreck off the coast of Greece, revealed a level of mechanical sophistication from the ancient world that was far beyond what historians had previously believed possible. While this device dates to about 2,000 years ago, not 100,000, it demonstrates that technological capabilities can appear earlier than expected and can be lost for long periods before being rediscovered. More controversially, there are reports of objects that seem to indicate much earlier technological development, metal artifacts found in geological formations that appear to be millions of years old, manufactured objects discovered in coal seams or embedded in rock, structures that seem too precisely engineered to be natural formations, but are found in contexts that predate known technological civilizations. The challenge with these discoveries is verification. Many lack proper documentation or have been contaminated by later materials. Others turn out to be natural formations that only appear artificial when viewed from certain angles or without proper geological context. And some may be hoaxes or misinterpretations by people who want to believe in alternative histories. But the persistence of such reports raises an important question. If genuine out-of-place artifacts do exist, how would we distinguish them from natural formations or more recent contamination? And how would we overcome the natural skepticism of the scientific community when such discoveries challenge fundamental assumptions about technological development? This problem becomes even more complex when we consider that an ancient advanced civilization might have developed along technological pathways completely different from our own. We tend to look for artifacts that resemble our own tools and technologies, but a civilization that followed different principles might have created objects that we wouldn't even recognize as artificial. Imagine, for example, a society that had mastered biological engineering rather than mechanical engineering. Their tools might have been grown rather than manufactured, designed to perform specific functions through biological processes rather than mechanical ones. When such tools reached the end of their useful life, they might have been programmed to decompose completely, leaving no trace for future archaeologists. Or consider a civilization that had developed advanced materials science based on principles we haven't yet discovered. They might have created substances with properties that seem impossible according to our current understanding of chemistry and physics. Such materials might appear to be natural formations to us simply because we lack the theoretical framework to recognize them as artificial. This possibility forces us to question our most basic assumptions about what constitutes evidence of intelligence and technology. We look for things that are obviously artificial, clearly different from natural patterns, but a truly sophisticated civilization might have moved beyond such crude distinctions, developing technologies that work so harmoniously with natural systems that they're indistinguishable from improved nature. Such technologies might be all around us, hidden in plain sight. The unusually efficient ecosystem might actually be a carefully designed biological machine. The strangely perfect crystal formation might be an artificial structure created through principles we don't understand. The plant with seemingly impossible properties might be the product of ancient genetic engineering. And this brings us to perhaps the most intriguing possibility of all, that evidence of ancient civilizations might be embedded not in artifacts or landscapes, but in the living systems of our planet itself. DNA is far more durable than stone or metal. Under the right conditions, genetic material can survive for hundreds of thousands of years. And if an ancient civilization had developed sophisticated biotechnology, they might have left traces of their work in the genomes of organisms that still exist today. Recent advances in genetic analysis have revealed that the history of life on Earth is far more complex than we previously imagined. Horizontal gene transfer allows genetic material to move between completely unrelated species. Viruses can insert foreign DNA into host genomes, where it may remain dormant for thousands of generations before being activated. And some organisms carry genetic sequences that seem to have no known function, but which might represent remnants of ancient biological modifications. What if some of these mysterious genetic sequences are actually the remnants of biotechnologies developed by an ancient civilization? What if certain organisms carry genetic programs that were designed rather than evolved, but which have been degraded by time and natural selection until their artificial origins are no longer obvious? Such genetic archaeology would be extraordinarily difficult to pursue with our current knowledge and technology. We would need to distinguish between natural genetic variation and artificial modifications that have been degraded by tens of thousands of years of evolution. We would need to understand not just how genes function today, but how they might have been designed to function in the past. But the potential rewards would be enormous. If we could identify genetic sequences that showed clear signs of intelligent design, if we could trace them back to their origins and understand their original functions, we might finally have undeniable proof that our planet has been home to technological civilizations far older than anything in our recorded history. Tonight, we've explored how the evidence of ancient civilizations might be hidden beneath the waves, preserved in cultural memory, embedded in controversial artifacts, or written in the genetic code of living organisms. Each of these possibilities faces enormous challenges of detection and interpretation, but each also offers the tantalizing prospect of revolutionizing our understanding of our planet's deep history. But perhaps the most disturbing possibility is that an ancient civilization might have destroyed itself. We know from our own experience how rapidly advanced technologies can become weapons of mass destruction. A society capable of manipulating matter and energy on a large scale would also be capable of using those same technologies for warfare or environmental destruction. Nuclear weapons represent just one possible path to self-destruction. An advanced civilization might have developed weapons based on principles we haven't yet discovered, or they might have deployed their technologies in ways that caused unintended environmental catastrophes. Genetic engineering could have led to the creation of deadly organisms that escaped containment. Geoengineering projects might have triggered irreversible climate changes. Industrial processes might have poisoned their environment beyond recovery. The self-destruction scenario is particularly troubling because it suggests that technological advancement might inevitably lead to existential risks. If intelligence naturally tends to develop technologies that can destroy their creators, then the absence of obvious alien civilizations in our galaxy might not be due to the rarity of intelligence, but to the tendency of advanced societies to eliminate themselves before they can expand beyond their home planets. This possibility carries obvious implications for our own civilization. We're already grappling with nuclear weapons, climate change, artificial intelligence, and biotechnology, any of which could pose existential risks if not managed carefully. If an ancient civilization on our own planet had faced similar challenges and failed to survive them, it would suggest that the path from technological advancement to long-term survival is narrower than we might hope. But self-destruction doesn't necessarily require dramatic weapons or environmental catastrophes. A civilization might collapse more gradually through social and economic factors. Resource depletion could undermine their technological base. Social inequality could lead to internal conflicts that destroyed their capacity for cooperation. Cultural changes could cause them to abandon the values and practices that had made their advancement possible. We can see examples of such gradual collapse in our own recorded history. Complex civilizations have risen and fallen many times, often leaving behind only ruins and legends. The Bronze Age collapse around 3,200 years ago saw multiple advanced civilizations across the Mediterranean and Near East suddenly disappear or revert to much simpler ways of life. The causes are still debated, but the result was a dark age that lasted for centuries. If such collapses can happen to civilizations we know about, civilizations that left behind extensive written records and monumental architecture, imagine how completely an older civilization might disappear if they collapsed before developing durable record-keeping systems or permanent monuments. And this brings us to perhaps the most sobering aspect of the entire question: the role of time itself in erasing not just physical evidence, but memory and meaning. Even if an ancient civilization had survived its initial catastrophe, even if some of their knowledge and technologies had been preserved, the passage of 100,000 years would have subjected that legacy to forces that are perhaps even more relentless than natural disasters. Cultural evolution operates much faster than biological evolution. Languages change beyond recognition within a few thousand years. Belief systems rise and fall. Technologies are invented, perfected, and then abandoned as circumstances change. Knowledge that seems essential in one era becomes irrelevant in another. Over 100,000 years, a society's descendants might have undergone so many cultural transformations that their original knowledge and technologies became not just lost but literally incomprehensible. Technical skills might have been preserved as ritual practices long after their original purpose was forgotten. Scientific knowledge might have been transformed into religious mythology. Practical technologies might have been simplified into crude imitations of their original forms. We can see hints of such processes in our own cultural record. Many traditional practices and beliefs appear to contain fragments of older knowledge that have been preserved in altered form. Traditional ecological knowledge often includes sophisticated understanding of natural systems, but encoded in stories and rituals rather than scientific language. Folk medicine sometimes contains genuine therapeutic insights, but mixed with supernatural explanations that obscure their empirical basis. If an advanced civilization had existed 100,000 years ago, their intellectual legacy might still be with us, but so transformed by cultural evolution that we can no longer recognize its origins. The deepest insights of ancient science might have been preserved as mythology. Their most sophisticated technologies might have devolved into simple tools and techniques that we assume arose independently during our own development. This possibility suggests that the search for evidence of ancient civilizations might require us to look not just for physical artifacts or chemical signatures, but for patterns of knowledge and practice that seem too sophisticated or too universal to have arisen independently in multiple cultures. Mathematical concepts that appear earlier than expected, agricultural techniques that seem too advanced for their supposed time period, astronomical knowledge that predates the instruments needed to make the relevant observations. Such indirect evidence would be extraordinarily difficult to interpret with confidence. How would we distinguish between knowledge that was genuinely inherited from an ancient civilization and insights that arose independently through human creativity and observation? How would we separate genuine artifacts of ancient science from coincidences and misinterpretations? But the possibility remains tantalizing. If we could identify clear examples of knowledge or technology that seem to require scientific understanding beyond what was supposed to exist at the time, it might provide crucial clues about the intellectual legacy of ancient civilizations. Such evidence wouldn't prove that a technologically advanced society existed 100,000 years ago, but it might suggest that the development of human knowledge has been far more complex and discontinuous than our current models assume. The destruction scenarios we've explored tonight, whether through climate change, volcanic catastrophe, asteroid impact, or self-destruction, all share a common theme. They could have reduced an advanced civilization to scattered survivors forced to rebuild from almost nothing. And once that rebuilding process began, it would have been subject to all the forces of cultural evolution and historical change that have shaped human societies throughout recorded history. Understanding how a civilization might have been destroyed also helps us understand how completely it might have been forgotten. The more catastrophic and rapid the collapse, the less likely that detailed knowledge about the previous civilization would have been preserved. Survivors focused on immediate needs for survival would have little time or resources for maintaining historical records or complex technologies. Within a few generations, the former civilization might have become nothing more than half-remembered stories told around fires by people struggling to survive in a transformed world. Within a few millennia, even those stories might have been lost or transformed beyond recognition. After 100,000 years, there might be nothing left but the faintest traces, scattered fragments that we lack the knowledge to interpret correctly. As we move deeper into our exploration tonight, we must grapple with one of the most challenging aspects of this entire question, the problem of time itself. When we talk about 100,000 years, we're dealing with a span so vast that it challenges our ability to comprehend what such duration really means for the preservation of evidence, memory, and meaning. To understand why traces of an ancient civilization might be so difficult to find, we need to truly grasp what 100,000 years represents in terms of change, decay, and transformation. This isn't just 20 times longer than recorded human history. It's long enough for ice ages to come and go multiple times. It's long enough for entire species to evolve, adapt, and go extinct. It's long enough for continents to shift perceptibly, and for the very chemistry of the atmosphere and oceans to change dramatically. Consider how quickly information can be lost even in our modern world. With all our technologies for preserving and transmitting knowledge, languages disappear when their last speakers die. Traditional skills vanish when younger generations choose different paths. Technical knowledge becomes obsolete when the conditions that made it relevant change. Cultural practices fade when social structures evolve. We've seen this happen repeatedly within the span of just a few centuries. Traditional shipbuilding techniques that took generations to perfect were lost within decades when steel and steam replaced wood and sail. Indigenous agricultural methods that sustained populations for thousands of years disappeared when colonial systems imposed different approaches. Entire bodies of astronomical knowledge accumulated through centuries of careful observation were abandoned when new theoretical frameworks made different kinds of observations seem more important. If such dramatic knowledge loss can occur within human lifetimes, imagine what could happen over thousands of lifetimes. Skills, technologies, and entire ways of understanding the world could be lost and rediscovered multiple times without leaving any clear record of the earlier developments. But the problem isn't just about preserving knowledge, it's about preserving the context that makes knowledge meaningful. A sophisticated technology might be maintained for centuries after its original purpose is forgotten, gradually degrading into a simpler form as each generation understands it less completely than the last. Eventually, what began as an advanced tool might become a crude implement with no remaining trace of its sophisticated origins. We can see hints of such processes in our own archaeological record. Many ancient technologies seem to have appeared suddenly, reached a peak of sophistication, and then declined or disappeared entirely. The Damascus steel techniques that produced superior swords were lost for centuries before being partially rediscovered through modern metallurgy. The Roman concrete that allowed construction of durable structures underwater was lost for more than 1,000 years. The Antikythera mechanism demonstrates a level of mechanical complexity that didn't reappear in European technology until more than a millennium later. These examples come from periods with written records, monumental architecture, and relatively good archaeological preservation. They demonstrate that even within recorded history, sophisticated technologies can be lost so completely that we only rediscover them through archaeological investigation or independent reinvention. If such dramatic technological loss can occur over centuries or millennia, what might happen over tens of thousands of years? An advanced civilization from 100,000 years ago might have experienced multiple cycles of development, decline, and partial recovery, with each cycle losing more of the original knowledge base. The survivors of a major catastrophe might have preserved fragments of their ancestors' technologies, but without the full context needed to maintain or develop them further. Over generations, these fragments would have been simplified, adapted to new circumstances, and gradually transformed into something quite different from their origins. Eventually, the descendants of an advanced civilization might have been living with tools and techniques that were actually degraded versions of much more sophisticated technologies, but which they understood only as traditional practices passed down from their ancestors. The original scientific principles might have been lost, leaving only empirical knowledge about what worked without understanding why it worked. Such a process could explain some of the puzzling aspects of human technological development. Why do certain innovations appear earlier than our models of technological progress would predict? Why do some traditional practices incorporate sophisticated understanding of complex systems? Why do certain mathematical or astronomical concepts appear in multiple cultures that supposedly had no contact with each other? If fragments of ancient scientific knowledge had been preserved in modified form through thousands of generations, they might have provided the foundation for later independent rediscoveries. What we interpret as remarkable human creativity and insight might sometimes be the result of building on half-remembered fragments from a much earlier period of achievement. But recognizing such inherited knowledge would be extraordinarily difficult. How would we distinguish between insights that were genuinely inherited from ancient civilizations and those that arose independently through human observation and reasoning? How would we separate authentic fragments of ancient science from coincidences and misinterpretations? This problem becomes even more complex when we consider that an ancient civilization might have developed along completely different technological pathways than our own. We tend to assume that technological development follows predictable patterns, that certain discoveries lead inevitably to certain applications. But there's no reason to believe that all intelligent species would develop technology in the same way. An ancient civilization might have focused on biological rather than mechanical technologies. Instead of building machines, they might have engineered living systems to perform the same functions. Instead of developing electronics, they might have created biological computers based on neural networks or cellular processes. Instead of using metals and ceramics, they might have grown materials with properties we haven't yet learned to achieve artificially. Such biotechnology might have been far more sophisticated than anything we can currently imagine, yet it would leave almost no archaeological trace. Living systems decompose when they die. Engineered organisms might have been designed to return to simpler forms when no longer maintained. Biological computers would rot away like any other organic matter. If an ancient civilization had mastered such biotechnology, their most advanced achievements might have looked like enhanced nature to any future investigators. Forests that were actually carefully designed ecosystems, organisms that were actually living machines, landscapes that were actually vast biological computers processing information through ecological interactions. We wouldn't recognize such technologies as artificial because they would function through biological processes that we understand as natural. Only by developing our own biotechnology to a similar level might we begin to recognize the signs of engineering in supposedly natural systems. This possibility raises profound questions about our understanding of nature itself. How do we know that the ecosystems we study as examples of natural evolution haven't been influenced by intelligence at some point in their history? How do we know that some of the organisms we consider purely natural haven't been modified by ancient genetic engineering? Recent discoveries in genetics have revealed that evolution is far more complex than early theories suggested. Horizontal gene transfer allows genetic material to move between unrelated species. Viruses can insert foreign DNA into host genomes. Symbiotic relationships can lead to permanent incorporation of one organism into another. These natural processes make it difficult to determine whether unusual genetic patterns represent natural evolution or artificial modification. If an ancient civilization had developed sophisticated genetic engineering, they might have left traces in the genomes of organisms that exist today. But distinguishing between natural genetic variation and ancient artificial modifications would require understanding not just how genes function now, but how they might have been designed to function tens of thousands of years ago. Such genetic archaeology would push the boundaries of what's possible with current technology. We would need to identify genetic sequences that showed clear signs of intelligent design rather than natural evolution. We would need to trace the history of these sequences back through thousands of generations. We would need to understand the original purposes and functions of genetic modifications that had been degraded by natural selection and genetic drift. But if such evidence could be found and properly interpreted, it would provide the most durable possible record of ancient intelligence. Unlike physical artifacts which can be destroyed by geological processes, or cultural traditions, which can be lost through social change, genetic modifications might persist for hundreds of thousands of years in the genomes of living organisms. This brings us to consider another dimension of the time problem: the possibility that evidence of ancient civilizations might be preserved in unexpected forms that we haven't yet learned to recognize. Traditional archaeology focuses on durable artifacts made from stone, metal, and ceramics. But what if an advanced civilization had developed information storage technologies that we haven't yet discovered? What if they had found ways to encode information in crystalline structures, in mineral formations, or in the atomic structure of materials? Such information storage might be far more durable than any physical artifact. It might survive geological processes that would destroy conventional artifacts. It might be preserved in materials that appear completely natural to us, but actually contain vast libraries of encoded information. Recent developments in our own information technology suggest that such possibilities aren't purely speculative. Researchers have demonstrated that information can be stored in DNA, in crystalline structures, and even in the quantum states of individual atoms. If we can develop such technologies with our current understanding, an ancient civilization with thousands of years to develop similar approaches might have achieved information storage densities and durability far beyond anything we can currently imagine. The information might be all around us, encoded in rocks, crystals, organic compounds, or even in the structure of landscapes and ecosystems. We might be surrounded by vast libraries of ancient knowledge without realizing it because we don't know how to read the encoding systems. This possibility suggests that the search for evidence of ancient civilizations might require us to develop entirely new analytical techniques. Instead of looking for conventional artifacts, we might need to search for patterns of information encoding in natural materials. Instead of excavating archaeological sites, we might need to analyze the information content of geological formations. Such investigations would push the boundaries of multiple scientific disciplines. We would need advances in materials science to understand how information might be encoded in different types of matter. We would need developments in computational analysis to recognize patterns in vast amounts of data. We would need new theoretical frameworks to understand how information might be preserved and transmitted across geological timescales. But perhaps the most challenging aspect of the time problem isn't the preservation of physical evidence or even information. It's the preservation of meaning itself. Even if we found clear evidence that an ancient civilization had existed, even if we discovered artifacts or information that were obviously artificial, we might still lack the context needed to understand what we had found. Imagine if future archaeologists discovered a computer hard drive from our civilization after 100,000 years had passed. Even if the physical device had somehow survived, they would face enormous challenges in extracting and interpreting the information it contained. They would need to understand our electronic systems, our data storage formats, our languages, and our cultural contexts. Without that understanding, even the most sophisticated information would be meaningless to them. The same challenges would apply to any evidence we might find of ancient civilizations. We might recognize that something was artificial without understanding what it was for, how it worked, or what it meant to the people who created it. We might find encoded information without being able to decode it. We might discover technologies without understanding the principles they were based on. This interpretive challenge becomes even more severe when we consider that an ancient civilization might have been based on knowledge systems completely different from our own. Their science might have been organized around different fundamental principles. Their mathematics might have used different logical foundations. Their technologies might have been based on aspects of nature that we haven't yet discovered or learned to manipulate. Such differences wouldn't just make their achievements difficult to understand. They might make them literally incomprehensible within our current conceptual frameworks. We might need to develop entirely new ways of thinking about matter, energy, information, and consciousness before we could begin to understand what an ancient civilization had achieved. And this brings us to perhaps the most profound implication of the time problem: the possibility that evidence of ancient civilizations might exist all around us. but remain invisible because we lack the knowledge and conceptual tools needed to recognize it. We might be living in a world that still bears the subtle marks of ancient intelligence, but we interpret those marks as natural phenomena because we don't understand how intelligence might express itself in ways different from our own experience. We might be surrounded by technologies so advanced that they appear to be laws of nature. We might be embedded in information systems so sophisticated that they're indistinguishable from the natural processes of the universe itself. Such possibilities push us to the very limits of what scientific investigation can achieve. How do we search for evidence of something when we don't know what form that evidence might take? How do we recognize intelligence when it might be expressed in ways we haven't yet learned to comprehend? These questions don't just apply to the search for ancient civilizations on our own planet. They also bear on our search for intelligence elsewhere in the universe. If advanced civilizations naturally develop in ways that make them difficult or impossible to detect using our current methods and assumptions, then the absence of obvious evidence for extraterrestrial intelligence might not mean that such intelligence is rare. It might mean that we're looking for the wrong things in the wrong ways. The time problem teaches us humility about the limits of our knowledge and our methods. It reminds us that absence of evidence is not evidence of absence, especially when we're dealing with timescales and possibilities that challenge our most basic assumptions about how information, meaning, and intelligence persist through time. Tonight, as we venture even deeper into this labyrinth of possibility, we must confront a question that strikes at the very heart of how we understand ourselves and our place in the cosmic story. What would it mean if we discovered tomorrow undeniable proof that an advanced civilization had existed on Earth 100,000 years ago? The implications would cascade through every aspect of human knowledge and belief, reshaping not just our understanding of history, but our conception of progress, uniqueness, and destiny itself. Such a discovery would demolish one of our most fundamental assumptions, that technological advancement is a recent achievement, that complex societies and sophisticated understanding of the natural world are innovations of the last few thousand years. We currently see ourselves as the culmination of a long, slow climb from primitive beginnings to modern sophistication. Finding evidence of comparable or superior achievement from the deep past would shatter that narrative completely. Instead of being the first civilization to develop agriculture, writing, mathematics, and technology, we would become merely the latest in what might be a very long series. Instead of representing the peak of human achievement, we would be revealed as just another point on a timeline that might include multiple rises and falls, multiple experiments in civilization, multiple attempts by intelligence to understand and shape the world. This realization would force us to confront the possibility that what we call human progress might actually be human recovery. Our gradual development of sciences and technologies might not represent the first time these insights have been achieved, but the rediscovery of knowledge that was once possessed and then lost. Our greatest intellectual achievements might be partial reconstructions of understanding that previous civilizations had developed more completely. The psychological impact of such a revelation would be profound. We derive much of our collective identity from the belief that we are unique, that our species represents something unprecedented in the history of life on Earth. The discovery that others had walked this path before us, perhaps multiple times, would challenge our sense of specialness and force us to reconsider what makes human civilization valuable. But beyond the psychological impact, such a discovery would raise immediate and practical questions that would reshape entire fields of study. If an advanced civilization had existed 100,000 years ago, why did it disappear? What can we learn from their apparent failure to achieve long-term survival? Are there patterns in the rise and fall of civilizations that we need to understand in order to avoid similar fates? These questions would become more than academic curiosities. They would become urgent practical concerns for our own survival. If previous civilizations had developed technologies similar to ours and then destroyed themselves, it might suggest that certain technological capabilities inevitably lead to existential risks. If they had been destroyed by natural catastrophes, It might indicate that we need to prepare for similar threats that could emerge at any time. The discovery would also revolutionize our approach to archaeology and historical research. If one advanced civilization could be hidden in our planet's deep past, there might be others. Suddenly, investigating much older time periods would become a priority rather than a curiosity. New methodologies would need to be developed to detect the subtle traces that ancient civilizations might leave behind. Funding would flow toward underwater archaeology, deep geological surveys, and advanced chemical analysis of ancient materials. Research priorities would shift dramatically, as investigators realized that some of the most important discoveries in human history might be waiting in places and time periods that had previously been considered unpromising. But perhaps most significantly, such a discovery would force us to reconsider our relationship with the natural world. If an advanced civilization had developed sustainable technologies that worked in harmony with natural systems, it might provide crucial insights for addressing our current environmental challenges. If they had achieved sophisticated understanding of ecological relationships, their knowledge might help us develop more sustainable approaches to energy, agriculture, and material science. Conversely, if their civilization had collapsed due to environmental destruction or resource depletion, it might serve as a warning about the long-term consequences of unsustainable development. Their failure might illuminate the specific mistakes that advanced civilizations tend to make, providing us with invaluable guidance for avoiding similar errors. The discovery would also have profound implications for our search for intelligence elsewhere in the universe. Currently, our methods for detecting extraterrestrial civilizations are based on the assumption that advanced societies would produce obvious large-scale signatures that would be detectable across interstellar distances. But if terrestrial advanced civilizations can exist without leaving easily detectable traces, it might suggest that our search strategies are fundamentally flawed. We might be looking for the wrong kinds of signals in the wrong places. If intelligence naturally develops in ways that minimize its environmental impact, or if advanced civilizations typically choose subtlety over obvious display, then the universe might be filled with intelligent life that remains invisible to our current detection methods. This possibility would require us to develop entirely new approaches to the search for extraterrestrial intelligence. Instead of looking for radio signals or megastructures, we might need to search for subtle modifications to planetary atmospheres, unusual patterns in the distribution of elements, or other indicators that intelligence has shaped the development of distant worlds. But the implications extend beyond science into philosophy and religion. Many belief systems are built around the assumption that humans occupy a special position in the universe, that we represent the culmination of a divine plan or the peak of evolutionary development. The discovery of previous advanced civilizations would challenge these assumptions directly. Some religious traditions might adapt by incorporating the new discoveries into existing theological frameworks, perhaps interpreting multiple civilizations as part of a larger divine plan, or as evidence of reincarnation on a civilizational scale. Others might face more fundamental challenges to their core doctrines about human uniqueness and divine purpose. Philosophical questions about consciousness, meaning, and purpose would become even more complex. If intelligence has emerged multiple times on Earth, reaching similar levels of sophistication, and then disappearing, what does that suggest about the nature of consciousness itself? Are we part of some larger pattern or process that operates on timescales far beyond human experience? The discovery would also have immediate political and social implications. Different nations and cultures might compete to claim connections to the ancient civilization, arguing that their traditions preserve authentic fragments of ancient knowledge, or that their territories contain the most important archaeological sites. International law would need to address questions about who has the right to investigate and control access to evidence of ancient civilizations. Should such sites be considered global heritage that belongs to all humanity, or do they fall under the sovereignty of whatever nation controls the territory where they're found? The economic implications could be equally significant. If the ancient civilization had developed technologies or materials that we haven't yet discovered, there might be enormous commercial value in understanding and reproducing their innovations. Companies and governments might invest massive resources in attempting to reverse engineer ancient technologies. But there would also be risks. If ancient technologies were based on principles we don't fully understand, attempts to reproduce them might lead to dangerous accidents or unintended consequences. The rush to exploit ancient knowledge might create new forms of technological risk that we're not prepared to manage. Educational systems would face the challenge of integrating radically new historical information into curricula that have been based on very different assumptions about human development. Textbooks would need to be rewritten, teachers would need to be retrained, students would need to learn to think about human history in completely different ways. The arts and popular culture would undoubtedly respond with a flood of creative works exploring the implications of ancient civilizations. Literature, films, and other media would attempt to imagine what these civilizations might have been like, how they might have lived, and why they might have disappeared. But artistic speculation might also create new problems. Fictional portrayals of ancient civilizations might become confused with factual information, leading to misconceptions about what had actually been discovered. The line between evidence-based knowledge and imaginative speculation might become blurred as popular culture struggled to process the implications of the discovery. Scientific methodology itself would face new challenges. How do you study a civilization that deliberately left minimal traces? How do you distinguish between evidence and speculation when dealing with phenomena that push the boundaries of what current analytical methods can detect? How do you maintain scientific rigor when investigating possibilities that challenge fundamental assumptions about the nature of evidence itself? New peer review processes might need to be developed to evaluate research into ancient civilizations. New standards of evidence might need to be established to distinguish between legitimate discoveries and wishful thinking. The scientific community would need to guard against both excessive skepticism that dismisses genuine discoveries and excessive credulity that accepts questionable claims. But perhaps the most profound long-term implication would be the change in how we think about time and continuity. We currently experience ourselves as part of a single continuous development of human civilization. We see our knowledge, our technologies, and our social systems as building directly on the achievements of previous generations going back to the beginning of recorded history. The discovery of much older advanced civilizations would break that sense of continuity. We would realize that we might be separated from previous peaks of human achievement by vast gulfs of time during which knowledge was lost, technologies were forgotten, and entire ways of understanding the world disappeared. This discontinuous view of human development would require us to think differently about progress, tradition, and innovation. Instead of seeing ourselves as part of a single ascending line of development, we would need to recognize that we might be part of a cyclical process in which civilizations rise, achieve sophisticated understanding of the world, and then fall back into simpler ways of life. Such a perspective might make us more humble about our own achievements, recognizing that what we consider unprecedented innovations might actually be rediscoveries of knowledge that others possessed before us. It might also make us more urgent about preserving and transmitting our knowledge, understanding that civilizations can lose their achievements more easily than we typically assume. But it might also be liberating in some ways. Understanding that civilizations can rise and fall might free us from the assumption that progress is inevitable, or that our current way of life is permanent. It might encourage us to think more carefully about what knowledge and achievements are truly worth preserving, and what aspects of our civilization might be improved rather than simply continued. The cyclical view of civilization might also help us develop more sustainable approaches to technology and social organization. Instead of pursuing endless growth and expansion, we might focus on creating systems that can persist through long periods of time and recover gracefully from disruptions. Perhaps most importantly, the discovery would remind us that we are part of something much larger than ourselves. Our individual lives, our particular civilization, and even our species might be just temporary manifestations of intelligence and consciousness that have appeared repeatedly throughout Earth's history and might continue to appear long after we're gone. This perspective might help us approach current challenges with both more urgency and more wisdom. More urgency because we would understand that our time might be limited and that the knowledge and achievements we create could be lost if we don't work to preserve them effectively. More wisdom because we would understand that we're part of a larger pattern that extends far beyond our immediate experience. The discovery of an ancient advanced civilization would transform not just our understanding of the past, but our approach to the future. It would force us to think more carefully about sustainability, preservation, and the long-term consequences of our choices. It would remind us that intelligence and consciousness are precious phenomena that deserve protection and nurturing. And it would challenge us to think about what legacy we want to leave behind, not just for our immediate descendants, but for whatever forms of intelligence might emerge on Earth in the distant future. What knowledge would we want to preserve? What achievements would we want to be remembered for? What mistakes would we want future civilizations to avoid? Such questions would become more than philosophical speculation. They would become practical challenges that could guide policy decisions, research priorities, and educational curricula. Understanding that civilizations can be lost might motivate us to work harder to ensure that ours can survive and contribute something valuable to the longer story of intelligence on Earth. The discovery would also raise profound questions about the nature of intelligence itself. If consciousness and technological capability have emerged multiple times on our planet, reaching similar levels of sophistication and then facing similar challenges, it might suggest that there are fundamental patterns or principles that govern the development of intelligence. These patterns might operate on timescales far beyond human experience, creating cycles of emergence, development, and transformation that span hundreds of thousands or millions of years. Understanding these patterns might help us position our own civilization more wisely within the larger flow of cosmic evolution. But such understanding would require us to develop new conceptual frameworks for thinking about intelligence, consciousness, and civilization. We would need to move beyond human-centered perspectives to consider how intelligence might manifest in forms and timescales that we haven't yet learned to recognize or comprehend. As we move through the deeper currents of this investigation tonight, we must turn our attention to one of the most compelling yet elusive forms of evidence: the possibility that traces of ancient knowledge might have survived not in artifacts or geological signatures, but in the collective memory of our species itself. Oral traditions represent one of humanity's most remarkable achievements in information preservation. Long before we developed writing systems, our ancestors created sophisticated methods for transmitting crucial knowledge across generations through stories, songs, rituals, and cultural practices. These systems were designed to preserve essential information about survival, navigation, astronomy, medicine, and social organization. What makes oral traditions particularly fascinating in the context of our investigation is their demonstrated ability to preserve accurate information across enormous spans of time. Aboriginal oral traditions in Australia have been shown to contain accurate descriptions of coastlines and geographical features that were submerged by rising seas more than 7,000 years ago. These stories, passed down through hundreds of generations, maintain sufficient detail and accuracy that modern researchers can use them to reconstruct ancient landscapes. If oral traditions can preserve accurate geographical information for 7,000 years, what about longer periods? Could some of the world's most persistent mythological themes actually represent cultural memories from much earlier times? Consider the remarkable consistency of certain mythological patterns across cultures that had no historical contact with each other. Flood narratives appear in traditions spanning every continent, often with strikingly similar details about global catastrophes that destroyed previous civilizations. Stories of golden ages describe times when humanity possessed great knowledge and lived in harmony with nature, only to lose these abilities through some catastrophe or moral failing. Creation myths frequently include accounts of earlier worlds or ages that were destroyed and replaced by the current world. Hindu cosmology describes vast cycles of time during which civilizations rise and fall repeatedly. Greek mythology speaks of multiple ages of humanity, including golden and silver ages that were far superior to the current Iron Age. Native American traditions describe previous worlds that were destroyed by various catastrophes, forcing survivors to rebuild in the current world. While these stories are typically interpreted as religious allegories or explanations for natural phenomena, their universal themes and specific details might preserve fragments of historical memory from periods so distant that the original events have been transformed into mythological narratives. The flood myths are particularly intriguing because they often include specific details that align with what we know about climate change at the end of the last ice age. Many describe waters rising to cover previous lands, forcing survivors to seek higher ground or build boats to escape the deluge. They speak of entire civilizations being lost beneath the waves, with only small groups surviving to restart human society. These details correspond remarkably well with the actual events that occurred as the last ice age ended. Sea levels did rise dramatically, submerging vast areas of previously habitable land. Coastal populations would have been forced to migrate inland or develop new survival strategies. Many settlements and possibly entire cultures could have been lost as their homelands disappeared beneath the rising seas. But the flood myths often include elements that suggest the lost civilizations might have been more advanced than simple hunter-gatherer societies. They speak of great cities, sophisticated technologies, and knowledge that was lost in the catastrophe. They describe survivors who carried fragments of the old wisdom to new lands, where they became the founders of later civilizations. If these stories preserve memories of real events, they might be describing the destruction of advanced societies that existed during or before the end of the last ice age. The mythological elements, the gods and magic that feature prominently in these narratives, might be later additions that accumulated as the original historical core was retold and reinterpreted through countless generations. Similarly, the Golden Age myths might preserve memories of periods when human societies had achieved levels of knowledge and technological capability that were later lost. The descriptions of harmony with nature, advanced understanding of natural laws and technologies that worked without environmental destruction, might reflect actual historical achievements that have been mythologized over time. But separating historical memory from mythological elaboration presents enormous challenges. Oral traditions change as they're transmitted through generations. Details are added, removed, or modified to fit the cultural context of each new telling. Symbolic and metaphorical elements become mixed with factual information. The supernatural gradually replaces the technological as cultures lose the knowledge needed to understand their own past. This means that even if oral traditions do preserve memories of advanced ancient civilizations, those memories would be heavily disguised by thousands of years of retelling and cultural evolution. We would need new methodologies for analyzing mythological narratives to separate potential historical kernels from later elaborations. Comparative mythology might provide some tools for this analysis. By comparing similar stories from cultures that had no historical contact, we might be able to identify common elements that could represent shared memories rather than independent inventions. Patterns that appear consistently across multiple unrelated traditions might point toward real historical events that preceded the divergence of these cultures. Linguistic analysis might also provide clues. Some ancient languages contain words and concepts that seem to refer to technologies or knowledge systems that supposedly didn't exist when those languages were formed. Archaeological linguistics, the study of how technological and cultural terms spread through language families, might reveal traces of lost knowledge preserved in vocabulary. But perhaps the most intriguing possibility is that some traditional practices and technologies might actually be degraded versions of much more sophisticated systems. Folk medicine often contains genuine therapeutic insights, but encoded in empirical knowledge rather than scientific understanding. Traditional ecological practices frequently incorporate sophisticated understanding of complex natural systems, but expressed through practical techniques rather than theoretical frameworks. What we interpret as primitive traditional knowledge might sometimes represent the survival of fragments from much more advanced understanding. A traditional navigation technique might be a simplified version of a sophisticated system that once included precise astronomical calculations. A folk remedy might be derived from detailed knowledge of biochemistry that has been reduced to empirical rules about which plants help which conditions. Agricultural practices provide some of the most compelling examples. Many traditional farming systems demonstrate remarkable sophistication in their understanding of soil chemistry, plant genetics, and ecological relationships. The Three Sisters agriculture of Native Americans, which combines corn, beans, and squash in symbiotic relationships, represents a complex understanding of how different plants can support each other's growth and nutrition. Terrace agriculture systems in places like Peru and Asia demonstrate advanced understanding of hydrology, soil conservation, and landscape engineering. These systems often require precise calculations about water flow, soil composition, and structural engineering that rival modern agricultural science. Some researchers have suggested that these sophisticated agricultural systems might have developed from even more advanced knowledge that has been partially lost over time. The precision and complexity of traditional ecological management systems might reflect the survival of fragments from much more comprehensive scientific understanding. Astronomical knowledge presents another fascinating case. Many traditional cultures possess detailed knowledge about celestial cycles, planetary movements, and stellar patterns that seems to require sophisticated observational techniques and mathematical analysis. The Dogon people of Mali have traditional knowledge about the star Sirius that includes details about its binary companion star, which wasn't discovered by European astronomy until the development of powerful telescopes. Polynesian navigation techniques demonstrate extraordinary understanding of ocean currents, stellar positions, wave patterns, and weather systems. These navigators could cross thousands of kilometers of open ocean using only traditional knowledge about natural phenomena, achieving accuracy that rivals modern navigation systems. Such sophisticated traditional knowledge might represent the preservation of scientific understanding that was developed during earlier periods of advanced civilization. The mathematical and observational skills required to develop these systems might have been much more extensive than what has survived in traditional form. But testing these possibilities requires us to develop new approaches to studying traditional knowledge. We need methodologies that can distinguish between knowledge that was developed gradually through cultural accumulation and knowledge that might represent fragments of more advanced understanding. We also need to overcome cultural biases that tend to dismiss traditional knowledge as primitive or unscientific. Many traditional practices that were once considered superstitious have been validated by modern science. Traditional ecological knowledge often incorporates understanding of complex systems that Western science is only beginning to appreciate. If some traditional knowledge does preserve fragments of advanced ancient science, then supporting and studying these traditions becomes crucial not just for cultural preservation, but for scientific advancement. We might be able to learn from ancient insights that could inform modern approaches to sustainability, medicine, agriculture, and environmental management. But we also need to be careful not to romanticize traditional knowledge or assume that everything ancient was necessarily advanced. The process of cultural transmission is messy and unreliable. Much traditional knowledge represents genuine innovation and insight developed through local experience and observation. Not every sophisticated practice needs to be explained by inheritance from lost civilizations. The challenge is developing criteria for distinguishing between knowledge that represents local innovation and knowledge that might have deeper historical roots. We need to identify patterns that suggest inheritance from more advanced sources while remaining open to the possibility that human creativity and observation have independently developed sophisticated understanding in many different contexts. This investigation of traditional knowledge connects to broader questions about how information and understanding persist through cultural change. Even if advanced civilizations had existed in the deep past, the knowledge they developed would have been subject to all the forces of cultural evolution that have shaped human societies throughout history. Understanding how knowledge survives, transforms, and sometimes disappears through cultural transmission might help us recognize fragments of ancient science that still exist in modified form. It might also help us understand what kinds of knowledge are most likely to survive civilizational collapse and what kinds are most vulnerable to being lost. Such understanding could have practical implications for our own civilization. If we knew more about how knowledge survives through cultural change, we might be able to design better systems for preserving crucial information through potential future disruptions. We might be able to identify which aspects of our current understanding are most important to maintain, and which methods of transmission are most reliable across long time periods. The study of traditional knowledge also raises questions about the relationship between formal scientific knowledge and practical understanding. Much traditional knowledge is embedded in practices and techniques rather than expressed in theoretical frameworks. This practical knowledge often works effectively without requiring comprehensive understanding of underlying principles. If ancient civilizations had developed sophisticated practical knowledge without necessarily developing formal scientific theories, their legacy might be preserved more in techniques and practices than in written explanations. We might be surrounded by inherited technologies that work well, but whose origins and principles have been forgotten. Understanding these possibilities requires us to look beyond obvious artifacts and written records to consider how knowledge and capability might be transmitted through cultural practices, traditional techniques, and collective memory. The search for evidence of ancient civilizations might need to include careful study of human cultural traditions as repositories of inherited understanding. As we continue our journey through these deep waters of possibility tonight, we must turn our attention to what might be the most radical and challenging aspect of this entire investigation: the notion that evidence of ancient civilizations might not be hidden away in remote archaeological sites or encoded in mysterious artifacts, but embedded in the very fabric of the natural world that surrounds us every day. This possibility forces us to question one of our most fundamental assumptions about the relationship between technology and nature. We tend to see these as opposing forces: technology as artificial intervention in natural processes, nature as the realm of unguided evolution and geological change. But what if this distinction is false? What if sufficiently advanced technology becomes indistinguishable from improved nature? Consider how our own understanding of technology has evolved over just the past few decades. Early technologies were crude and obviously artificial: steam engines, mechanical clockwork, industrial machinery that clearly stood apart from natural systems. But as our understanding has grown more sophisticated, our technologies have become more subtle and more integrated with biological processes. We now engineer organisms to produce medicines and materials. We design systems that mimic natural processes for energy production and information processing. We're beginning to understand how to work with ecological systems rather than simply imposing mechanical solutions. Our most advanced technologies increasingly blur the line between artificial and natural. Now imagine what technologies might look like after thousands of years of such development. A civilization that had perfected biotechnology might create systems that were indistinguishable from enhanced natural ecosystems. Their energy systems might appear to be ordinary forests or grasslands, but actually be carefully designed biological machines for capturing and storing solar energy. Their transportation networks might look like natural river systems, but actually be engineered waterways optimized for efficiency and sustainability. Their cities might appear to be natural landscape features, but actually be living systems designed to support large populations while maintaining perfect ecological balance. Their manufacturing might be performed by engineered organisms that produce materials through biological processes, leaving no industrial waste or environmental impact. Such a civilization might achieve technological capabilities far beyond anything we've imagined, while leaving an environmental footprint that appeared completely natural to future investigators. They might manipulate matter and energy on scales that we can barely comprehend, but do so through biological and ecological systems that enhanced rather than disrupted natural processes. If such technologies had existed, their traces might be everywhere around us, but we would interpret them as ordinary natural phenomena because we lack the knowledge to recognize the signs of intelligence in systems that work through biological rather than mechanical principles. That forest ecosystem that seems unusually diverse and productive might actually be a carefully designed biological computer processing information through the interactions between different species and environmental factors. The river system that flows in a particularly efficient pattern might be following an artificially optimized course designed to maximize both transportation efficiency and ecological health. The mineral deposits that seem too convenient and accessible might actually be the products of biological mining systems that concentrated valuable materials through engineered bacterial processes. The organisms with seemingly impossible biochemical capabilities might be the descendants of ancient genetic engineering projects, their artificial origins obscured by thousands of generations of evolution. This possibility is particularly compelling because it would explain why we haven't found obvious traces of ancient civilizations despite the statistical likelihood that they should have existed. If advanced civilizations naturally develop toward biotechnology and ecological integration, then their most sophisticated achievements would be invisible to archaeological methods designed to detect mechanical artifacts and industrial infrastructure. We wouldn't recognize advanced biotechnology as technology at all. We would classify it as natural phenomena and miss its artificial origins entirely. Our archaeological methods are optimized for finding stone tools, metal objects, and permanent structures, not for detecting biological systems that have been enhanced through intelligence. But how could we test such a possibility? How would we distinguish between natural ecosystems and artificially enhanced ones? What would constitute evidence of intelligence in biological systems? This challenge pushes us to the very limits of what current science can achieve. We would need to develop entirely new analytical methods, new theoretical frameworks, and new ways of thinking about the relationship between intelligence and biological processes. One approach might involve looking for patterns of organization and efficiency that exceed what we would expect from purely natural evolution. Natural selection tends to produce systems that are good enough for survival and reproduction, but not necessarily optimal from an engineering perspective. Artificial design might achieve levels of efficiency and integration that natural processes rarely reach. We might look for ecosystems that demonstrate unusual stability, productivity, or complexity compared to similar natural systems. We might search for biological processes that seem to incorporate principles of advanced engineering or information processing. We might investigate organisms whose biochemical capabilities seem to exceed what we would expect from gradual evolutionary development. But such investigations would require us to develop much more sophisticated understanding of natural systems than we currently possess. We would need to understand not just how biological processes work, but how they could be optimized through intelligent intervention. We would need to distinguish between natural complexity and artificial enhancement. Recent advances in understanding biological complexity have revealed that natural systems often incorporate principles that seem remarkably sophisticated from an engineering perspective. Bacterial colonies coordinate their behavior through chemical communication networks that resemble distributed computing systems. Plant root networks share information and resources through fungal connections that function like biological internet systems. Some researchers have even suggested that certain aspects of biological organization might require intelligence to explain. The complexity of cellular biochemistry, the precision of genetic regulatory systems, and the efficiency of ecological relationships sometimes seem to exceed what random processes could achieve within the time available for evolution. While these observations don't necessarily indicate artificial origins, they do suggest that the line between natural and artificial organization might be much blurrier than we typically assume. Intelligence might express itself through biological systems in ways that we haven't yet learned to recognize. This brings us to consider another radical possibility, that intelligence itself might be a much more fundamental feature of natural systems than we currently understand. What if consciousness and intentionality are not rare accidents that emerged only recently in biological evolution, but basic properties of matter and energy that operate on timescales and in ways that we haven't yet learned to detect? Such a perspective would suggest that the search for ancient civilizations might require us to look not just for technological artifacts, but for signs of intelligence and intentionality in natural systems themselves. The question wouldn't be whether ancient civilizations left technological traces, but whether we can learn to recognize the signatures of intelligence in the natural world. This possibility connects to some of the deepest questions in science and philosophy. What is consciousness? How does intelligence relate to physical processes? Are there forms of awareness and intentionality that operate through natural systems in ways that we don't yet understand? While these questions push beyond the bounds of current scientific knowledge, they might be relevant to understanding how ancient civilizations could have developed and what traces they might have left behind. If intelligence can express itself through natural processes, then the boundaries between technological and natural development might be much more permeable than we assume. But we must also consider the possibility that our investigation might be leading us astray. The absence of obvious evidence for ancient civilizations might simply mean that no such civilizations existed. The gaps in our archaeological record might reflect the actual limits of technological development rather than the erasure of evidence by time and natural processes. Most of the ideas we've explored tonight remain highly speculative. While they're consistent with our current understanding of geology, biology, and archaeology, they go far beyond what can be proven with available evidence. They represent possibilities rather than established facts, scenarios that could explain certain puzzles rather than definitive solutions to historical questions. The scientific method requires skepticism and caution when evaluating extraordinary claims. The more remarkable a possibility, the more evidence we should require before accepting it as likely. And the evidence for advanced civilizations from 100,000 years ago, while intriguing, remains indirect and incomplete. We must also be careful not to let our investigations slide into pseudoscience or wishful thinking. The desire to believe in ancient advanced civilizations can lead to misinterpretation of natural phenomena, overinterpretation of ambiguous evidence, and acceptance of claims that haven't been properly verified. But skepticism shouldn't prevent us from exploring legitimate scientific questions or considering possibilities that challenge conventional assumptions. Science advances by investigating ideas that seem unlikely but might be true, by developing new methods for testing hypotheses that couldn't previously be evaluated. The question of ancient civilizations pushes us to examine the limits of our knowledge and our methods. It forces us to consider how much we really know about our planet's deep history, and how confident we should be in conclusions based on incomplete evidence. Even if no advanced civilizations existed 100,000 years ago, the process of investigating this possibility has value. It helps us understand the limitations of archaeological methods, the challenges of preserving information across geological timescales, and the difficulties of detecting intelligence that might express itself in unfamiliar ways. It also encourages us to think more carefully about our own civilization's relationship with natural systems, about the sustainability of our current technological approaches, and about the kinds of traces we might leave for future investigators to discover or miss. The investigation reminds us that our understanding of history, consciousness, and intelligence remains profoundly incomplete. We may be just beginning to develop the concepts and methods needed to understand how intelligence has expressed itself on our planet over deep time. Whether or not ancient advanced civilizations actually existed, the possibility forces us to expand our thinking about what's possible, about how intelligence might develop and express itself, and about our place in the larger story of consciousness and complexity in the universe. Tonight, we've explored how intelligence might have left traces not just in artifacts and geological signatures, but in biological systems, cultural traditions, and perhaps even in the fundamental organization of natural processes themselves. These possibilities push us to the very limits of current scientific understanding, challenging us to develop new ways of thinking about intelligence, technology, and the relationship between consciousness and natural systems. As we drift toward the gentle embrace of sleep tonight, I want to take a moment to connect with you, our incredible Simply About Earth community, wherever you might be watching from. If this journey through deep time and ancient possibilities has resonated with you, if you found yourself wondering about the mysteries we've uncovered together, I would be truly grateful if you could subscribe to Simply About Earth. Your subscription not only supports our channel, but helps these contemplative explorations reach other curious minds who might find comfort and wonder in questioning the vast unknowns that surround us. And if you know other science-minded souls who appreciate this kind of gentle, thought-provoking content, especially those who enjoy drifting off to sleep while pondering the cosmos, please consider sharing this video. There's something beautiful about knowing that people all around the world are falling asleep while contemplating the same infinite questions about our place in the universe. Before you settle into your dreams tonight, I'd love to hear from you in the comments. Where in the world are you watching from? And what time is it there right now? Are you feeling content as you prepare for sleep? Or perhaps your mind is still buzzing with all the possibilities we've explored together? And here's something I'm always curious about. Do you have any stories or experiences that make you wonder about the deep mysteries of time and consciousness? Perhaps something that happened to you that felt connected to the vast spans of history we've been discussing, or a moment when you felt the weight of all the time that came before us and all that might come after. Whatever thoughts are flowing through your mind right now, know that you're part of something beautiful. Each person watching this, wherever you are, whatever time zone you're in, is connected to all the others who have shared this journey through the deepest questions about our planet's hidden history. As you close your eyes tonight, let your mind wander gently through all we've discovered together. The vast underwater realms that might hold secrets from ages past, the possibility that our ancestors achieved wonders we can barely imagine, the humbling recognition that we might not be the first to look up at the stars and wonder about our place in the cosmic story. Let these thoughts flow like a gentle river, carrying you peacefully towards sleep. Rest in the knowledge that the universe is far more mysterious and wonderful than we often remember in our daily lives. Rest knowing that every question we've explored tonight opens doorways to even greater mysteries waiting to be discovered. Sleep well, fellow explorers. May your dreams be filled with ancient wonders and future possibilities. And remember, whether we're the first civilization to ask these questions or the latest in a long line of questioners, we're all part of the same magnificent story of consciousness seeking to understand itself. Good night, and thank you for being part of the Simply About Earth family. But before we conclude our journey into the deep mysteries of time tonight, there are still more profound dimensions to explore, questions that push even further into the realm of what's possible, what's probable, and what might fundamentally change how we understand our species and our world. We've discussed the possibility that evidence of ancient civilizations might be preserved in chemical signatures, in genetic codes, in oral traditions, and in the very structure of natural systems around us. But there's another category of potential evidence that deserves careful consideration: the possibility that traces of advanced ancient knowledge might be hidden in the most unlikely places within the mathematical and scientific principles that govern our universe itself. This brings us to one of the most mind-bending possibilities we'll explore tonight. What if some of the fundamental constants, ratios, and relationships that we observe in physics, mathematics, and natural systems aren't just arbitrary features of reality, but engineered signatures left behind by intelligences that understood the deep structure of the universe far better than we currently do? Consider the mathematical constants that appear throughout nature, the golden ratio in spiral galaxies and flower petals, the precise relationships between planetary masses and orbital periods, the exact values of fundamental forces that allow atoms to form and stars to shine. We typically assume these are simply features of how reality happens to be constructed. But what if some of these relationships represent something more deliberate? What if ancient civilizations had achieved such profound understanding of mathematics and physics that they could manipulate the fundamental parameters of reality itself? This possibility sounds like pure science fiction, but it connects to some serious questions that physicists are already asking. Why do the fundamental constants of the universe have exactly the values they do? Why is the fine structure constant precisely what it is? Why are the ratios between the masses of subatomic particles arranged in just the right way to allow complex chemistry to exist? These questions have led some researchers to propose what's called the anthropic principle, the idea that the universe appears to be fine-tuned for the existence of intelligence because if it weren't, we wouldn't be here to observe it. But there's another possibility, that the apparent fine-tuning isn't a cosmic coincidence, but evidence of engineering by intelligences that came before us. If this sounds impossibly advanced, consider what we're already beginning to learn about the relationship between information, consciousness, and physical reality. Quantum mechanics suggests that observation and measurement play a fundamental role in determining the behavior of matter and energy. Some interpretations even suggest that consciousness might be a basic feature of the universe rather than just an emergent property of complex brains. Information theory tells us that the distinction between matter and information might be much blurrier than we once thought. Recent developments in physics suggest that space, time, and matter might all be emergent properties of something more fundamental, patterns of information processing that we don't yet understand. If consciousness and information are indeed fundamental features of reality, then the possibility that advanced intelligences could manipulate the basic parameters of physics becomes less fantastical and more intriguing. An ancient civilization that had developed complete understanding of the relationship between consciousness, information, and physical reality might have been able to engineer changes that would persist for millions or billions of years. They might have left signatures in the mathematical structure of the universe itself, subtle modifications to the fundamental constants that would appear natural to observers who hadn't achieved their level of understanding. Such modifications would be the ultimate form of long-term information storage. While physical artifacts decay and even genetic information degrades over time, changes to the fundamental constants of physics would persist for the entire lifetime of the universe. But how could we possibly detect such engineered modifications? How would we distinguish between natural mathematical relationships and artificially imposed ones? This is where the investigation becomes truly challenging. We would need to develop ways of analyzing the mathematical structure of reality that go far beyond our current capabilities. We would need to understand not just how the universe works, but how it could work differently, what the natural values of fundamental constants should be versus what they actually are. Some researchers have already begun exploring these questions from different angles. Studies of fine-tuning in physics have revealed that many of the fundamental constants appear to be balanced on knife edges. Tiny changes in their values would make the formation of atoms, stars, or complex chemistry impossible. The question is whether this apparent fine-tuning represents cosmic coincidence, multiple universe scenarios where we happen to exist in one that works, or something more deliberate. Mathematical analysis of natural patterns has revealed unexpected connections and relationships that seem too elegant and precisely arranged to be entirely accidental. The appearance of the golden ratio in everything from galaxy spirals to flower petals, the mathematical relationships underlying musical harmony, the geometric patterns that govern crystal formation and cellular growth. While these patterns are usually explained as natural consequences of physical laws and evolutionary processes, some researchers have wondered whether the elegance and precision of these relationships might indicate something more purposeful. If ancient civilizations had achieved mastery over the fundamental forces of nature, they might have arranged these mathematical relationships as a form of cosmic signature, a way of indicating to future intelligences that conscious design had played a role in shaping the structure of reality. But this possibility raises profound philosophical questions about the nature of intelligence, consciousness, and reality itself. If the mathematical structure of the universe contains traces of ancient engineering, what does that tell us about the relationship between mind and matter? Are we living in a universe that has been consciously designed, at least in part? Such questions push us into territory that's part science, part philosophy, and part metaphysics. We're asking not just whether ancient civilizations existed, but whether they achieved levels of understanding and capability that allowed them to manipulate reality at the most fundamental level. This investigation also connects to questions about the nature of time itself. Our exploration tonight has focused primarily on civilizations that might have existed 100,000 years ago, ancient by human standards, but recent in cosmic terms. But what if the timescales we need to consider are much faster? What if the engineering of fundamental constants happened not thousands or millions of years ago, but billions of years ago, during the early formation of the universe itself? This possibility would suggest that intelligence and consciousness have been present in the universe for far longer than we typically assume. Instead of being recent, emergent properties of biological evolution, mind and intentionality might be fundamental features of reality that have been shaping the development of the cosmos from the very beginning. Such a perspective would radically transform our understanding of evolution, consciousness, and our place in the cosmic story. Instead of being accidental byproducts of random processes, we might be the natural result of purposeful development that has been unfolding for billions of years. But these ideas also force us to confront the limits of what scientific investigation can achieve. How do we test hypotheses about the fundamental nature of reality when we're embedded within that reality and have no external reference point for comparison? How do we distinguish between patterns that result from conscious design and patterns that emerge naturally from the mathematical structure of existence? These questions might require us to develop entirely new methodologies, ways of thinking about evidence, causation, and explanation that go beyond the current boundaries of science. The investigation of ancient civilizations through mathematical and physical signatures represents perhaps the most ambitious frontier in our search for evidence of intelligence in deep time, but it also represents the most uncertain territory, speculation that pushes far beyond what can currently be verified or even properly tested. Yet, even if these possibilities remain forever beyond our ability to prove, the process of considering them has value. It stretches our thinking about what intelligence might be capable of achieving. It challenges our assumptions about the relationship between mind and matter. It forces us to consider whether the universe itself might contain information and meaning in ways we haven't yet learned to recognize. As we continue deeper into the night, let's explore another dimension of this vast mystery: the possibility that traces of ancient civilizations might be preserved not just in physical or mathematical signatures, but in the collective unconscious of our species. This brings us into territory that bridges science and psychology, archaeology and depth psychology, empirical investigation, and the exploration of human consciousness itself. Carl Jung proposed that all humans share what he called the collective unconscious, a layer of the psyche that contains universal patterns, symbols, and themes that appear across all cultures and historical periods. Jung suggested that these archetypal patterns represent inherited psychological structures that have been shaped by the common experiences of our species over hundreds of thousands of years. But what if some of these archetypal patterns preserve not just general human experiences, but specific memories of actual historical events and achievements that occurred in the deep past? What if the recurring symbols, myths, and psychological themes that appear in human consciousness across all cultures actually represent fragments of inherited memory from periods when our ancestors achieved levels of knowledge and capability that were later lost? This possibility connects to emerging research in epigenetics, the study of how environmental experiences can create heritable changes in gene expression that persist across generations. We're discovering that traumatic experiences, environmental stresses, and even learning can create molecular modifications that are passed down to offspring. If experiences can create heritable biological changes, is it possible that the psychological and cultural achievements of ancient civilizations could have left traces in the inherited structure of human consciousness? The universal appearance of certain symbols and themes across all human cultures is striking. The mandala pattern, circular designs with central focal points, appears in the art, architecture, and spiritual practices of cultures that had no historical contact. The tree of life symbol shows up in mythologies from every continent, The spiral pattern appears in art and sacred designs across all human societies. These universal symbols are usually explained as arising from common features of human psychology or shared experiences like observing natural patterns. But what if some of these symbols preserve memories of actual technologies, architectural forms, or knowledge systems from ancient civilizations? The mandala pattern, for example, bears striking resemblance to how we might represent complex energy systems, information networks, or even the structure of engineered ecosystems. The tree of life could be a stylized representation of actual knowledge about genetic relationships, evolutionary processes, or even biotechnological systems that connected different forms of life. The spiral pattern appears not just in art, but in many natural phenomena that an advanced civilization might have studied or manipulated: galaxy formation, weather systems, fluid dynamics, growth patterns in living organisms. If ancient civilizations had developed sophisticated understanding of these natural processes and had incorporated that knowledge into their technologies and social systems, the psychological impact of living with such understanding might have created lasting impressions in human consciousness. These impressions could have been preserved through the very process of cultural transmission, not just in stories and practices, but in the deeper psychological structures that shape how humans perceive, think, and create meaning. The investigation of consciousness as a repository of ancient memory faces enormous methodological challenges. How do we distinguish between archetypal patterns that arise naturally from the structure of human psychology and patterns that might preserve specific historical information? How do we separate universal symbols that reflect the common features of human experience from symbols that might encode memories of particular achievements or events? But there are some intriguing approaches we might consider. Comparative analysis of symbols and themes across cultures could help identify patterns that seem too specific or too technically sophisticated to arise independently from general psychological processes. Dream research might provide another avenue for investigation. If ancient memories are preserved in the collective unconscious, they might surface most readily in dreams and other altered states of consciousness, where normal cognitive filters are relaxed. Studies of child psychology and development might reveal whether certain complex symbols and concepts appear in young minds before they could have been learned through cultural transmission, suggesting that they might be inherited rather than acquired. Neuroscience research into the biological basis of archetypal patterns might help us understand whether certain psychological structures are hardwired into the brain in ways that could preserve specific information across generations. But perhaps the most promising approach would be to study traditional cultures that have maintained continuous oral traditions and spiritual practices for thousands of years. If these traditions preserve fragments of ancient knowledge in psychological and symbolic form, careful analysis might reveal technical or scientific insights that couldn't have been developed through the resources available to these cultures. The investigation of consciousness as a repository of ancient memory also raises profound questions about the nature of knowledge, memory, and cultural transmission. If humans can inherit not just biological traits, but also psychological and cultural information, what does that tell us about the relationship between individual consciousness and collective human experience? Are we separate individuals who happen to share common cultural influences? Or are we expressions of a deeper collective intelligence that has been accumulating knowledge and experience across the entire history of our species? Such questions push us toward a more expanded understanding of consciousness, one that sees individual minds as participants in larger patterns of intelligence that operate across timescales far beyond individual lifetimes. This perspective might help explain some of the puzzling aspects of human creativity and insight. The sudden appearance of revolutionary ideas, the independent discovery of the same concepts by different people in different places, the ability of some individuals to access knowledge that seems to exceed what they could have learned through normal means. If consciousness participates in collective patterns of intelligence that transcend individual experience, then creative insights might sometimes represent the accessing of knowledge that exists at levels beyond personal memory, including knowledge that might trace back to achievements from the deep past. The exploration of consciousness as a potential repository of ancient memory brings us into territory that challenges the boundaries between science and spirituality, between empirical investigation and the exploration of inner experience. Many spiritual traditions have long maintained that human consciousness contains layers of knowledge and memory that go far beyond individual experience. Practices like meditation, contemplation, and visionary states are often described as ways of accessing deeper levels of understanding that connect individual awareness to universal patterns of intelligence. If these traditional understandings contain elements of truth, they might provide tools for investigating the possibility that ancient knowledge has been preserved in the structure of consciousness itself. But such investigations would require developing new methodologies that could bridge the gap between subjective experience and objective verification, ways of studying consciousness that honor both the rigor of scientific method and the insights that emerge from the exploration of inner experience. As we venture even deeper into the mystery tonight, let's consider another dimension that might preserve traces of ancient civilizations: the possibility that advanced societies from the past might have developed technologies for storing information in quantum systems that could persist across enormous spans of time. Recent developments in quantum physics have revealed that information can be encoded in quantum states in ways that are far more stable and durable than traditional information storage methods. Quantum entanglement allows information to be preserved in systems of particles that remain connected across vast distances and potentially vast time periods. If ancient civilizations had achieved understanding of quantum mechanics far in advance of our current knowledge, they might have developed methods for encoding information in quantum systems that would remain stable for millions or billions of years. Such information storage systems would be virtually undetectable using conventional archaeological methods. They might exist all around us, encoded in the quantum states of materials, landscapes, even living organisms, but remain invisible to our current detection technologies. The information might be embedded in the quantum structure of crystals, in the coherent quantum states of biological systems, or even in the quantum foam that underlies space-time itself. It could be preserved in quantum patterns that appear random to us, but actually contain vast libraries of encoded knowledge. Detecting such quantum information storage would require technologies and theoretical understanding far beyond our current capabilities. We would need to develop methods for reading quantum information without destroying it, techniques for distinguishing between natural quantum noise and artificially encoded patterns, and theoretical frameworks for understanding how complex information could be preserved in quantum systems over geological timescales. But the possibility is tantalizing. If ancient civilizations had achieved mastery over quantum information storage, they might have preserved not just records of their achievements, but their entire knowledge base, complete archives of science, technology, philosophy, and cultural understanding that could be accessed by any future civilization that developed the necessary decoding technologies. Such quantum archives might even be interactive, designed to respond to the specific questions and needs of whoever accessed them. They could contain not just static information, but dynamic knowledge systems that could adapt their responses to the level of understanding of the inquirer. The investigation of quantum information storage as a method for preserving ancient knowledge pushes us to the very frontiers of what's scientifically conceivable. It requires us to consider possibilities that sound like science fiction, but are actually consistent with our emerging understanding of quantum mechanics and information theory. Even if such quantum archives don't exist, the process of considering them helps us expand our thinking about how intelligence might preserve and transmit knowledge across vast spans of time. It challenges us to move beyond conventional assumptions about information storage and to consider radically new possibilities for how civilizations might leave traces for future discovery. The quantum information hypothesis also connects to broader questions about the nature of reality and consciousness. If information is indeed a fundamental feature of the universe, as some physicists suggest, then the boundary between mind and matter, between consciousness and physical reality, might be much more permeable than we typically assume. Advanced civilizations that understood these connections might have developed technologies that work through consciousness itself, systems that could be accessed not through mechanical devices, but through states of awareness and understanding that align with the quantum patterns where the information is stored. Such consciousness-based information systems would represent the ultimate integration of technology and awareness, tools that could only be used by minds that had achieved sufficient understanding and development to interface with quantum information patterns. The possibility of consciousness-based quantum information storage brings us full circle to some of the deepest questions we've explored tonight. If ancient civilizations achieved such profound integration of technology and consciousness, they might have left traces that can only be detected by minds that approach their level of understanding. This would mean that the search for evidence of ancient civilizations isn't just a matter of developing better detection technologies or analytical methods. It's also a matter of expanding human consciousness and understanding to the point where we become capable of recognizing and interpreting the evidence that might be all around us. Such a perspective suggests that the investigation of ancient civilizations is ultimately an investigation of the potential of consciousness itself. The question isn't just whether advanced societies existed in the past, but whether we can develop the understanding and awareness necessary to detect the traces they might have left behind. This brings us to consider the role that the exploration of consciousness expansion and human potential might play in uncovering evidence of ancient civilizations. If advanced knowledge has been preserved in quantum information systems that can only be accessed through expanded states of awareness, then practices like meditation, contemplation, and other consciousness-expanding techniques might be essential tools for archaeological investigation. Traditional cultures around the world have long maintained that altered states of consciousness can provide access to knowledge and information that isn't available through ordinary awareness. Shamanic practices, mystical traditions, and contemplative methods are often described as ways of accessing universal knowledge or communicating with intelligence that transcends individual experience. If these traditional understandings contain elements of truth, they might provide practical methods for investigating the possibility that ancient knowledge has been preserved in quantum or consciousness-based information systems. But such investigations would require developing rigorous methodologies for studying subjective experience and consciousness-based information gathering. We would need ways of distinguishing between genuine access to preserved ancient knowledge and the many forms of self-deception, wishful thinking, and cultural projection that can occur in altered states of consciousness. We would need protocols for verifying information obtained through consciousness-based methods, criteria for evaluating the authenticity and accuracy of insights that emerge from expanded awareness, and theoretical frameworks for understanding how consciousness might interface with quantum information systems. The investigation of consciousness-based access to ancient knowledge represents perhaps the most challenging frontier in our exploration tonight. It requires us to consider possibilities that push far beyond the current boundaries of scientific methodology, while still maintaining intellectual rigor and healthy skepticism. Yet even if consciousness-based information access proves to be impossible or unverifiable, the process of exploring these possibilities has value. It encourages us to expand our understanding of consciousness, information, and the potential relationships between mind and matter. It challenges us to consider new methodologies for investigation and new ways of thinking about evidence and verification. As we move through the deepest waters of this investigation tonight, we must also consider the possibility that the question of ancient civilizations connects to some of the most profound mysteries about the nature of time itself. Our entire exploration has been based on linear assumptions about time, the idea that ancient civilizations existed in the past and left traces that we might discover in the present. But what if time itself is far more complex and mysterious than our everyday experience suggests? Modern physics has revealed that time is not the simple, uniform flow that we experience in daily life. Einstein's relativity showed us that time can slow down or speed up depending on gravity and velocity. Quantum mechanics suggests that at the smallest scales, the normal rules of cause and effect might not apply. Effects can sometimes precede causes, and particles can exist in multiple states simultaneously. Some interpretations of quantum mechanics suggest that all possible timelines exist simultaneously, and what we experience as the linear flow of time is just one perspective on a more complex multidimensional reality. If time is indeed more complex than linear progression from past to future, advanced societies might not just have existed in the past, they might exist in parallel timelines, alternate dimensions, or entirely different relationships to time than we currently understand. This possibility would mean that traces of advanced civilizations might not be hidden in archaeological sites or geological records, but embedded in the fabric of space-time itself. They might exist as quantum echoes from parallel timelines, as information patterns in higher dimensional spaces, or as conscious influences that operate outside the normal flow of linear time. Detecting such temporally complex traces would require understanding and technologies far beyond our current capabilities. We would need to develop ways of perceiving and analyzing reality that go beyond our three-dimensional linear time perspective. But the possibility is intriguing. If consciousness and intelligence can indeed transcend the normal limitations of space and time, then the search for ancient civilizations might ultimately become a search for ways of expanding our awareness beyond the constraints of ordinary experience. This brings us to consider whether the investigation of ancient civilizations might be pointing towards something much larger, the possibility that intelligence and consciousness are fundamental features of reality that operate across scales and time frames far beyond what we normally consider. If consciousness is indeed a basic property of the universe rather than just an emergent property of complex brains, then intelligence might be present everywhere and everywhen, operating through natural processes guiding the evolution of complexity and manifesting in forms that we haven't yet learned to recognize. From this perspective, the question wouldn't be whether ancient civilizations existed, but whether we can develop the understanding and awareness necessary to recognize the presence of intelligence in all its forms, past, present, and future. Such a recognition might reveal that we're not isolated individuals struggling to understand a meaningless universe, but participants in a vast cosmic intelligence that has been unfolding for billions of years and will continue to evolve long after our current forms of life have passed away. The search for ancient civilizations might ultimately be a search for understanding our place in this larger pattern of cosmic intelligence, a way of recognizing that consciousness and purpose are not rare accidents, but fundamental features of reality itself. This perspective would transform not just our understanding of history, but our understanding of our own nature and potential. Instead of being accidental byproducts of random processes, we would be expressions of universal intelligence, temporary focal points of consciousness that participate in patterns of awareness and understanding that transcend individual experience. As we approach the gentle conclusion of our journey tonight, let's consider what all of these possibilities, from chemical signatures to quantum information storage, from genetic archaeology to consciousness-based investigation, might ultimately mean for how we live and understand ourselves. Whether or not ancient advanced civilizations actually existed, the process of exploring these possibilities has revealed something profound about the nature of knowledge, consciousness, and reality itself. It has shown us that the boundaries between mind and matter, between natural and artificial, between past and present, might be much more fluid than we typically assume. It has challenged us to expand our thinking about what intelligence might be capable of achieving, what forms consciousness might take, and what kinds of evidence we should be looking for when we investigate the deep mysteries of existence. The exploration has also revealed the limitations of our current scientific methodologies and the need for new approaches to investigation that can bridge the gap between objective and subjective experience, between empirical analysis and the exploration of consciousness itself. Most importantly, it has reminded us that we are part of something much larger than ourselves, participants in a cosmic story of intelligence and consciousness that extends far beyond our individual lives and immediate experience. Whether ancient civilizations achieved technological mastery, consciousness expansion, or integration with the fundamental forces of nature, their potential existence points toward possibilities for our own development and understanding that are far more vast and profound than we typically imagine. The search for traces of ancient intelligence ultimately becomes a search for understanding the full potential of consciousness itself, an exploration of what awareness might be capable of achieving when it develops beyond the limitations of our current understanding. This investigation reminds us that consciousness is not just something we have, but something we are, and something that we might be capable of expanding, developing, and integrating with the deeper patterns of intelligence that operate throughout the universe. As you drift towards sleep tonight, let these vast possibilities flow through your awareness like gentle streams carrying you toward rest. Whether ancient civilizations existed or not, the cosmos itself is filled with intelligence, purpose, and meaning that extends far beyond what we can currently comprehend. Rest in the knowledge that you are part of this larger pattern of cosmic intelligence, a unique expression of consciousness exploring itself through your individual experience. Your questions, your wonder, your capacity for awe and understanding, these are not accidents but expressions of the universe's own desire to know and understand itself. Sleep well, knowing that the mystery is vast, beautiful, and ultimately friendly to consciousness and understanding. Whatever ancient intelligences may have existed, whatever traces they may have left behind, the same cosmic intelligence that potentially expressed itself through them is expressing itself through you right now. Dream deeply of the vast possibilities we've explored together, and wake tomorrow with renewed appreciation for the profound mystery and beauty of existence itself. The search for ancient civilizations is ultimately a celebration of consciousness and intelligence in all its forms, past, present, and yet to be discovered. Good night, fellow explorers of the infinite mystery. May your dreams be filled with wonder, and may you wake with deeper appreciation for the magnificent cosmic story, of which you are an irreplaceable part. But our journey through the depths of possibility isn't quite complete. There are still more layers to peel back, more questions to explore, more profound implications to consider as we drift through these twilight hours of contemplation. Let's venture into perhaps the most challenging territory of all, the possibility that what we call ancient civilizations might not be ancient at all, but represent something far more complex and mysterious about the nature of reality itself. What if the traces we've been seeking, the chemical signatures, the genetic modifications, the consciousness patterns, the quantum information storage, aren't remnants from the past, but echoes from parallel dimensions of existence that interpenetrate our own reality in ways we're only beginning to understand? Modern physics has revealed that the universe is far stranger than our everyday experience suggests. Quantum mechanics tells us that particles can exist in multiple states simultaneously until they're observed. String theory proposes that reality consists of multiple dimensions beyond the three spatial dimensions and one time dimension that we normally experience. The many worlds interpretation of quantum mechanics suggests that every quantum event creates branching timelines, with all possible outcomes occurring simultaneously in parallel universes. From this perspective, our reality is just one branch of an infinite tree of possibilities. But what if some of these parallel realities developed along different trajectories than our own? What if in some dimensions intelligence and consciousness evolved much earlier, achieved far greater understanding of natural laws, and developed technologies that transcend the limitations we currently face? If parallel dimensions do exist, and occasionally interpenetrate our own reality, then what we interpret as evidence of ancient civilizations might actually be cross-dimensional bleed-through, traces of advanced societies that exist not in our past, but in parallel presents where evolution, consciousness, and technology follow different pathways. This possibility would explain some of the puzzling aspects of the evidence we've explored tonight. Why do certain chemical signatures appear in our geological record with no clear source? Perhaps they're cross-dimensional contamination from realities where different industrial processes developed. Why do some organisms carry genetic sequences that seem too sophisticated to have evolved naturally? Perhaps they're the result of genetic modifications that occurred in parallel dimensions and somehow crossed over into our reality. Why do human consciousness and mythology contain universal patterns and symbols that appear across all cultures? Perhaps they're reflections of knowledge and understanding that developed in parallel realities and somehow leaked into our collective awareness. The cross-dimensional hypothesis would also explain why evidence of advanced civilizations seems so elusive and contradictory. We're not looking at the straightforward archaeological remains of societies that existed in our own timeline, but at fragmentary traces from entirely different versions of reality. Such traces would naturally appear incomplete, ambiguous, and difficult to interpret, because they come from contexts where the laws of physics, the course of evolution, and the development of consciousness follow different patterns than in our own dimension. Investigating cross-dimensional traces would require developing entirely new methodologies, ways of detecting and analyzing phenomena that exist at the intersection between parallel realities. We would need to understand not just how our universe works, but how it relates to other possible versions of reality. But the cross-dimensional hypothesis raises profound questions about the nature of identity, causation, and meaning. If our reality is constantly being influenced by parallel dimensions, what does that tell us about the autonomy and significance of our own choices and achievements? Are we independent agents creating our own future, or are we part of a vast multidimensional system where all possibilities exist simultaneously and influence each other in ways we don't understand? These questions push us into territory that's part physics, part philosophy, and part metaphysics. They challenge our most basic assumptions about the nature of existence and our place within it. But they also open up extraordinary possibilities for understanding consciousness, intelligence, and the potential for communication and interaction across the boundaries of parallel realities. If advanced civilizations do exist in parallel dimensions, and if some form of cross-dimensional communication is possible, then the search for ancient wisdom might ultimately become a search for ways of making contact with intelligence that exists in other versions of reality. Such contact might provide access to knowledge, technologies, and understanding that developed along entirely different evolutionary pathways. It might reveal solutions to problems that seem intractable in our own dimension, insights into the nature of consciousness and reality that we couldn't achieve through our own investigation alone. But cross-dimensional communication would also carry enormous risks and responsibilities. How do we ensure that contact with parallel realities doesn't disrupt the natural development of consciousness and civilization in our own dimension? How do we maintain our own authenticity and autonomy while learning from intelligence that might be far more advanced than our own? These questions become even more complex when we consider the possibility that consciousness itself might be the medium through which cross-dimensional interaction occurs. If awareness transcends the boundaries between parallel realities, then expanded states of consciousness might naturally provide access to knowledge and experience from other dimensions. This perspective would suggest that practices like meditation, contemplation, and other consciousness-expanding techniques aren't just ways of exploring our own inner experience, but methods for accessing the vast multidimensional network of intelligence that spans all possible realities. From this viewpoint, the search for ancient civilizations becomes a search for understanding how consciousness operates across dimensional boundaries, how awareness can transcend the limitations of any single reality, and participate in larger patterns of intelligence that encompass all possible worlds. Such understanding might reveal that we're not isolated individuals in a single universe, but participants in a vast cosmic consciousness that exists across all dimensions simultaneously. Our individual awareness would be just one focal point of this larger intelligence, temporary expressions of universal consciousness exploring itself through infinite variations of experience. The multidimensional perspective also suggests new ways of thinking about time, causation, and the relationship between past, present, and future. If all possible timelines exist simultaneously in parallel dimensions, then what we experience as the linear flow of time might be just one way of navigating through the multidimensional landscape of possibilities. Advanced consciousness might be able to move freely through this landscape, accessing knowledge and experience from any point in any timeline. From such a perspective, the distinction between ancient and modern, past and future, would become much less meaningful. This possibility connects to mystical and spiritual traditions that have long maintained that enlightened consciousness transcends the ordinary limitations of time and space. Reports of precognition, telepathy, and other psychic phenomena might reflect natural capabilities of consciousness when it operates beyond the constraints of single-dimensional awareness. If consciousness can indeed transcend dimensional boundaries, then the development of human awareness might eventually lead to natural access to the vast network of intelligence that spans all possible realities. We might be evolving toward forms of consciousness that can communicate directly with advanced civilizations in parallel dimensions. But this evolution would require fundamental changes in how we understand ourselves and our relationship to reality. We would need to let go of the assumption that we're separate individuals in an isolated universe and embrace our identity as expressions of universal consciousness, participating in infinite patterns of possibility. Such a transformation would have profound implications for every aspect of human life: science, technology, social organization, spiritual practice, and individual psychology. It would require developing new ways of thinking, being, and relating that honor both our unique individual perspective and our participation in larger patterns of cosmic intelligence. The multidimensional hypothesis also suggests that the search for evidence of ancient civilizations might ultimately be unnecessary. If all possible forms of intelligence and civilization exist simultaneously in parallel dimensions, then every conceivable level of advancement, every possible form of knowledge, every imaginable technology already exists somewhere in the vast landscape of multidimensional reality. The question wouldn't be whether ancient civilizations existed, but how we can develop the consciousness and understanding necessary to access the infinite wisdom that already exists across all possible worlds. This perspective transforms the investigation of ancient civilizations from an archaeological or historical inquiry into a consciousness development project, a systematic exploration of how awareness can expand beyond the limitations of single-dimensional experience. But even if the multidimensional hypothesis proves to be accurate, it doesn't diminish the value of our exploration tonight. Understanding the possibilities and implications of cross-dimensional intelligence helps us expand our conception of what consciousness might be capable of achieving. It challenges us to think beyond the constraints of our current scientific paradigms and to consider new possibilities for investigation, understanding, and human development. Whether ancient civilizations existed in our own timeline in parallel dimensions or in some combination of both, the process of exploring these possibilities stretches our thinking and opens us to new ways of understanding consciousness, intelligence, and reality itself. As we continue deeper into the night, let's explore another dimension of this vast mystery: the possibility that the question of ancient civilizations connects to some of the deepest secrets about the nature of evolution itself. Our current understanding of evolution is based on the assumption that complex forms of life and intelligence arise gradually through random mutations and natural selection operating over millions of years. But what if this process is guided or influenced by intelligence that operates on much larger scales than we currently recognize? What if consciousness itself is an evolutionary force that guides the development of complexity, intelligence, and understanding throughout the universe? If consciousness is indeed a fundamental feature of reality rather than just an emergent property of complex brains, then it might play an active role in shaping the course of evolution itself. This possibility would suggest that the evolution of intelligence on Earth isn't just a random accident, but part of a larger pattern of cosmic development that has been unfolding for billions of years under the guidance of universal consciousness. From this perspective, ancient advanced civilizations wouldn't be anomalies that contradict our understanding of evolutionary development, but natural expressions of the accelerated evolution that occurs when consciousness becomes sufficiently organized and focused. If consciousness can indeed influence evolutionary processes, then intelligent beings might be able to guide their own development and the development of their environment in ways that transcend the normal limitations of biological evolution. An ancient civilization that understood the relationship between consciousness and evolution might have been able to accelerate their own development, enhance their environment, and even guide the evolution of other species in ways that created lasting benefits for all life on their planet. Such evolutionary engineering might explain some of the puzzling aspects of biological development that we observe today. Why did certain crucial evolutionary developments occur so rapidly? Why do some biological systems seem more sophisticated and well-designed than we would expect from random processes alone? If intelligence has been guiding evolutionary development for much longer than we currently assume, then the apparent fine-tuning and sophistication of biological systems might reflect not just natural selection, but conscious design by advanced forms of life that understood how to work with evolutionary forces. This possibility connects to emerging research in fields like epigenetics and developmental biology, which have revealed that evolution is far more dynamic and responsive to environmental influences than early theories suggested. Organisms can modify their gene expression in response to environmental changes, and these modifications can sometimes be passed on to offspring. Learning and experience can create heritable changes that affect the development of future generations. If consciousness can indeed influence biological processes, then the focused intention and understanding of advanced civilizations might have been able to create lasting evolutionary changes that continue to influence biological development long after the original designers disappeared. Such evolutionary legacy systems might be operating all around us without our recognition. The apparent intelligence and purposefulness of biological development, the remarkable efficiency and integration of ecological systems, the sophisticated information processing capabilities of living organisms, all of these might reflect the ongoing influence of evolutionary engineering that was initiated by ancient advanced civilizations. But consciousness-guided evolution also raises profound questions about the nature of free will, autonomy, and natural development. If evolutionary processes have been influenced by intelligence, what does that tell us about the authenticity and spontaneity of biological development? Are we observing genuine natural evolution, or are we seeing the unfolding of a vast biological program that was designed and initiated by earlier forms of intelligence? These questions become even more complex when we consider the possibility that consciousness-guided evolution might be operating at multiple levels simultaneously. Individual organisms might be guided by their own consciousness. Species might be guided by collective intelligence, ecosystems might be guided by planetary consciousness, and the entire evolutionary process might be guided by cosmic intelligence. From this perspective, evolution wouldn't be a random process, but a vast, multi-level system of conscious development where intelligence operates at every scale to guide the emergence of greater complexity, understanding, and capability. Such a system would naturally produce what appears to be fine-tuning and intelligent design, because intelligence would indeed be operating at every level to optimize development and create conditions for continued advancement. The consciousness-guided evolution hypothesis also suggests new possibilities for human development and the future of our species. If we can understand how consciousness influences evolutionary processes, we might be able to participate more consciously in our own development and the development of our environment. Instead of being passive subjects of random evolutionary forces, we might become active participants in guided evolution, consciously directing our biological, psychological, and spiritual development in ways that enhance our capabilities and contribute to the larger patterns of cosmic evolution. Such conscious participation in evolution would require developing much deeper understanding of the relationship between consciousness, biology, and environmental systems. We would need to learn how to work with evolutionary forces rather than simply trying to dominate or control them. But the potential benefits would be enormous. Conscious evolution might allow us to overcome current limitations in human capability, to develop more harmonious relationships with our environment, and to participate more effectively in the larger patterns of cosmic intelligence. The investigation of consciousness-guided evolution also connects to questions about the ultimate purpose and direction of evolutionary development. If evolution is indeed guided by intelligence, what is it moving toward? What kind of consciousness, capability, and understanding is the universe trying to develop? Some possibilities that emerge from our exploration tonight include consciousness that can transcend the boundaries between dimensions, intelligence that can participate directly in the fundamental forces of nature, awareness that can access universal knowledge and understanding, and capabilities that allow conscious beings to participate as co-creators in the ongoing development of reality itself. If these represent the natural direction of evolutionary development, then ancient advanced civilizations might not be anomalies from the past, but previews of what consciousness and intelligence naturally evolve toward when given sufficient time and optimal conditions. Our own species might be in the early stages of a transformation that will eventually lead to capabilities and understanding that rival or exceed anything achieved by ancient civilizations. The traces we've been seeking might not just be remnants from the past, but glimpses of our own future potential. This perspective transforms the search for ancient civilizations from a purely historical investigation into an exploration of human potential and cosmic destiny. Understanding what consciousness might have achieved in the past helps us envision what it might be capable of achieving in the future. But conscious evolution also carries enormous responsibilities. If we are indeed capable of guiding our own development and influencing the course of evolution on our planet, then our choices and actions have implications that extend far beyond our immediate experience. We become responsible not just for our own well-being, but for the well-being of all life on Earth and the continuation of the evolutionary process that has been unfolding for billions of years. Such responsibility requires wisdom, humility, and deep understanding of the interconnected nature of all existence. We would need to learn to think and act from the perspective of cosmic intelligence rather than just individual or even species self-interest. The consciousness-guided evolution hypothesis suggests that this expansion of perspective and responsibility might be a natural part of the evolutionary process itself. As consciousness develops greater capability and understanding, it naturally expands its circle of concern and begins to think and act from increasingly universal perspectives. Ancient advanced civilizations that achieved high levels of development might have naturally evolved beyond narrow self-interest to embrace responsibility for the well-being of all life and the continuation of cosmic evolution. Their apparent disappearance from the archaeological record might reflect not failure or destruction, but graduation to levels of existence and activity that transcend the need for physical artifacts and obvious environmental impact. Such evolved civilizations might still be present and active, but operating at levels of subtlety and integration that make them invisible to our current detection methods. They might be working to guide and support the evolutionary development of younger civilizations like our own, but doing so in ways that preserve our autonomy and allow us to develop our own understanding and capabilities. This possibility connects to spiritual and mystical traditions that speak of evolved beings, ascended masters, or cosmic intelligences that work behind the scenes to support human development and planetary evolution. If such beings exist, they would represent the natural outcome of the evolutionary process we've been exploring tonight. Consciousness that has developed to the point where it can transcend physical limitations and operate directly through the fundamental forces that govern reality. Contact or communication with such evolved intelligence might be possible through the development of sufficient consciousness and understanding, but such contact would likely require that we demonstrate the wisdom and responsibility necessary to handle advanced knowledge and capability without causing harm to ourselves or others. The possibility of guidance from evolved intelligence adds another layer to our investigation of ancient civilizations. We might not just be looking for traces of past achievements, but for ongoing influence from consciousness that has evolved beyond the need for obvious physical presence. Such influence might be operating through the very processes we've explored tonight: genetic guidance that influences biological development, consciousness patterns that shape human psychology and culture, quantum information systems that provide access to universal knowledge, and environmental modifications that support continued evolution toward greater intelligence and capability. From this perspective, the investigation of ancient civilizations becomes an investigation of how consciousness evolves and how evolved intelligence continues to participate in cosmic development. The traces we've been seeking might not be remnants from the past, but ongoing influences that are actively shaping our present and future development. Understanding this possibility requires expanding our conception of intelligence, consciousness, and the nature of existence itself. We need to consider forms of awareness and capability that transcend our current experience, while remaining open to the guidance and influence that might be available to support our own evolutionary development. As we drift deeper into the gentle currents of night, let's explore one final dimension of this vast mystery. The possibility that our entire investigation tonight has been pointing toward a profound truth about the nature of consciousness and reality that transcends the specific question of whether ancient civilizations existed. Perhaps the real discovery isn't about particular societies that might have existed in the past, but about the unlimited potential of consciousness itself, the recognition that awareness, intelligence, and understanding are fundamental features of reality that can develop and express themselves in ways that far exceed our current imagination. Every possibility we've explored tonight, from genetic archaeology to quantum information storage, from consciousness-based investigation to multidimensional intelligence, points toward the same underlying truth that consciousness is not a rare accident or a temporary byproduct of complex chemistry, but a primary feature of existence that can develop capabilities and understanding that transcend every limitation we currently face. If this recognition is accurate, then the question of ancient civilizations becomes just one small part of a much larger exploration, the investigation of what consciousness is ultimately capable of achieving when it develops beyond the constraints of our current experience. This investigation reveals that we are not separate individuals struggling to understand a meaningless universe, but expressions of universal consciousness exploring its own infinite potential through countless forms of experience and understanding. From this perspective, every question we ask, every mystery we explore, every limitation we encounter becomes an opportunity for consciousness to expand its understanding of itself and its capabilities. The search for ancient civilizations becomes a search for understanding our own deepest nature and highest potential. The traces we seek in the past become reflections of the possibilities that exist within consciousness itself, waiting to be discovered and developed. This recognition transforms not just our understanding of history, but our understanding of what it means to be conscious, to be human, and to be alive in this vast and mysterious universe. Whether ancient civilizations existed or not, consciousness itself contains unlimited potential for development, understanding, and creative expression. We are not bound by the limitations of our current experience, but are capable of evolving toward levels of awareness and capability that we can barely imagine. The investigation of ancient possibilities becomes an invitation to explore our own future potential, to develop the consciousness and understanding that would allow us to achieve whatever levels of advancement might have been reached by civilizations from the past. In this way, the search for ancient wisdom becomes a process of discovering the wisdom that already exists within consciousness itself, waiting to be uncovered through dedicated exploration and development. As you prepare for sleep tonight, let this recognition settle gently into your awareness. You are not just an observer of these vast mysteries, but a participant in the ongoing evolution of consciousness itself. Your capacity for wonder, your ability to ask profound questions, your openness to extraordinary possibilities, these are expressions of the universe's own drive toward greater understanding and development. Rest tonight, knowing that you are part of something infinitely larger and more magnificent than anything we've explored together. The same consciousness that might have expressed itself through ancient civilizations is expressing itself through you right now, exploring its own nature and potential through your unique perspective and experience. Sleep deeply, dream wonderfully, and wake tomorrow with renewed appreciation for the profound mystery and unlimited potential of consciousness itself. The greatest archaeological discovery isn't hidden in the past. It's waiting to be uncovered within the infinite depths of your own awareness. Sweet dreams, fellow explorers of the infinite mystery of consciousness. Welcome to Part 2, where we continue our gentle exploration into the deepest mysteries our planet holds. If you've joined us from our previous journey into the possibility of ancient advanced civilizations, you already know that tonight we're venturing even further into territories that challenge everything we think we know about reality, time, and consciousness itself. For those discovering us for the first time, settle in. We're about to embark on a contemplative exploration that will stretch your understanding of what's possible. If you find yourself drawn to these kinds of profound investigations, the type that invite you to question the very foundations of existence while maintaining a sense of wonder and scientific curiosity, I'd be truly grateful if you could hit that like button and consider subscribing to Simply About Earth. Your support helps us continue creating these deep dive explorations for minds that crave more than surface level explanations. Tonight, we're picking up where we left off, at the threshold of recognizing that the search for ancient civilizations might be pointing towards something far more profound than historical discovery. We're beginning to understand that consciousness itself, your consciousness, my consciousness, the awareness reading these words right now, might be the key to unlocking mysteries that have puzzled humanity for millennia. But what if our exploration has only scratched the surface? What if the implications of ancient advanced civilizations extend into realms of possibility that would fundamentally transform not just our understanding of the past, but our comprehension of what reality itself actually is? Tonight, we're going to explore the possibility that ancient civilizations didn't just possess advanced technology or superior knowledge, but achieved states of consciousness and understanding that allowed them to interact with the fundamental structure of reality in ways that we're only beginning to glimpse through the cutting edge of modern physics and consciousness research. What if they discovered that consciousness isn't just something that observes reality, but something that actively participates in creating it? This possibility emerges from some of the most puzzling discoveries in modern quantum physics. We've learned that the act of observation appears to influence the behavior of subatomic particles. The famous double-slit experiment demonstrates that photons behave differently when they're being observed versus when they're not, suggesting that consciousness itself plays a fundamental role in determining the nature of physical reality. But what if this relationship between consciousness and reality is far more profound and practical than we currently understand? What if advanced ancient civilizations discovered that focused, disciplined consciousness could directly influence not just subatomic particles but matter and energy at every scale? Such a discovery would represent a revolution in understanding that goes far beyond anything we've achieved with conventional technology. Instead of building machines to manipulate the physical world, these civilizations might have developed their consciousness to the point where awareness itself became the ultimate tool for shaping reality. This possibility would explain many of the puzzling aspects we explored in our previous investigation. Why do we find no obvious technological artifacts from these advanced societies? Perhaps because they transcended the need for external technology by developing their consciousness to function as a more powerful and elegant form of technology. Why do the traces of their influence appear so subtle and integrated with natural systems? Perhaps because consciousness-based technology naturally works in harmony with the fundamental patterns that underlie all existence. Why do their achievements seem to blur the line between technological advancement and spiritual development? Perhaps because at the highest levels of understanding, there is no meaningful distinction between scientific knowledge and spiritual wisdom. They represent different aspects of the same fundamental truth about the nature of consciousness and reality. If ancient civilizations did achieve this level of consciousness development, their legacy wouldn't be found in physical artifacts or even chemical signatures, but in the enhanced potential for consciousness development that they might have woven into the very fabric of reality itself. They might have created what we could call consciousness enhancement fields, subtle modifications to the structure of space-time that make it easier for aware beings to access higher states of consciousness and develop their inherent capabilities. Such fields might be operating all around us, invisible to our instruments but directly accessible to sufficiently developed awareness. They could be embedded in certain geographical locations, activated by specific practices or states of consciousness, or even woven into the genetic and psychological heritage of humanity itself. This possibility transforms the search for evidence of ancient civilizations into a search for understanding and developing our own consciousness. The most profound archaeological discoveries might not be found by digging in the earth, but by exploring the depths of our own awareness. But what would it mean to develop consciousness to the point where it could directly influence physical reality? This question takes us into territory that challenges our most basic assumptions about the relationship between mind and matter. Our current scientific worldview treats consciousness as an emergent property of complex brain chemistry, essentially a sophisticated biological computer processing information about an objective external reality. But quantum physics has begun to reveal that this simple picture might be fundamentally incomplete. The observer effect in quantum mechanics suggests that consciousness plays an active role in determining the properties of physical systems. Some interpretations go even further, proposing that consciousness is a fundamental feature of reality rather than just an emergent property of complex matter. If consciousness is indeed fundamental to reality, then developing our awareness might not just give us better understanding of the world around us, it might give us the ability to participate more directly in the ongoing creation and evolution of reality itself. Ancient civilizations that achieved this level of understanding would have discovered that the ultimate technology isn't external manipulation of matter and energy, but internal development of consciousness to the point where it can interface directly with the creative forces that shape existence. Such consciousness technology would be far more powerful and elegant than anything we've achieved through conventional science. Instead of building crude machines that force matter to behave in desired ways, developed consciousness could work with the natural creative processes of the universe to manifest whatever was needed. But this level of capability would require forms of mental discipline, emotional development, and spiritual understanding that go far beyond anything currently achieved by most humans. It would require transforming consciousness from its ordinary state of fragmented, reactive awareness into something much more coherent, focused, and aligned with universal principles. The development of such consciousness wouldn't happen accidentally or quickly. It would require systematic cultivation over long periods of time, probably involving entire civilizations dedicated to the exploration and development of awareness itself. This possibility helps explain why ancient advanced civilizations might have appeared to disappear from the archaeological record. They didn't necessarily die out or destroy themselves. They might have graduated to levels of existence where physical artifacts and obvious environmental manipulation became unnecessary. A civilization that had developed consciousness to this degree might continue to exist and influence reality, but in ways that are virtually undetectable to societies that haven't achieved similar levels of development. They might be operating from dimensions of reality that interpenetrate our own, but remain invisible to ordinary perception. This perspective also suggests new ways of thinking about human potential and the future of our species. Instead of focusing primarily on external technological development, we might benefit from dedicating more attention to the systematic development of consciousness itself. What if the next great leap in human evolution isn't about building better machines, but about developing better minds? What if the solutions to our current challenges, environmental destruction, social conflict, existential risks from technology, require not just technical innovations, but fundamental expansions in human consciousness and wisdom? The investigation of consciousness as a creative force in reality also connects to ancient traditions of knowledge that have maintained for thousands of years that developed awareness can directly influence the physical world. Traditions of meditation, yoga, qigong, and other consciousness practices have long claimed that sufficiently developed awareness can affect healing, manifest desired outcomes, and even influence weather and natural phenomena. While these claims have been dismissed by mainstream science, They might represent preserved fragments of understanding from civilizations that achieved far greater development of consciousness than we currently possess. If this is accurate, then these traditional practices might not just be ancient superstitions or psychological techniques, but practical methodologies for developing the same consciousness technologies that advanced ancient civilizations once mastered. Studying and practicing these traditional approaches with scientific rigor might provide pathways for rediscovering capabilities that our species once possessed, but lost during periods of civilizational collapse and knowledge degradation. But developing consciousness as a technology for influencing reality would require understanding principles and practicing disciplines that go far beyond our current educational and cultural systems. It would require integrating scientific understanding with contemplative practice, technical knowledge with wisdom development, and individual growth with collective evolution. Such integration would represent a fundamental transformation in human civilization, a movement toward forms of knowledge and capability that transcend the current limitations of both scientific materialism and traditional spirituality. This transformation might already be beginning. The convergence of quantum physics and consciousness research, the growing interest in meditation and contemplative practices, the emerging understanding of the relationship between individual and collective consciousness. All of these might be early signs of a species-wide movement toward rediscovering consciousness technologies that ancient civilizations once mastered. But this rediscovery would need to happen gradually and wisely. The power to directly influence reality through consciousness would carry enormous responsibilities. A civilization that developed such capabilities without corresponding wisdom and ethical development could easily cause tremendous harm to themselves and their environment. The apparent disappearance of ancient advanced civilizations might serve as a warning about the risks involved in developing consciousness technologies without sufficient wisdom and restraint. Perhaps they achieved great power but lacked the wisdom to use it responsibly, leading to outcomes that forced them to withdraw from obvious interaction with the physical world. Or perhaps their wisdom was so profound that they recognized the importance of allowing younger civilizations to develop their own understanding rather than providing shortcuts that might prevent the natural growth of wisdom and capability. This possibility suggests that contact with advanced consciousness from ancient civilizations might not come through archaeological discovery or technological detection, but through our own development of sufficient awareness and wisdom to merit such contact. The traces we seek might not be hidden in the past, but accessible in the present to consciousness that has developed enough coherence and understanding to recognize and interact with intelligence that operates at higher levels of reality. From this perspective, the investigation of ancient civilizations becomes a path of personal and collective development, a process of growing into the level of consciousness that would allow us to directly experience whatever wisdom and capability previous civilizations might have achieved. But what would such development actually involve? How might we begin to cultivate the kind of consciousness that could interact directly with the creative forces of reality? This question takes us into the practical dimensions of consciousness development, the specific disciplines and practices that might be necessary for achieving states of awareness that transcend our current limitations. The first requirement would probably be developing much greater coherence and stability in our ordinary consciousness. Most human awareness is fragmented, reactive, and inconsistent, constantly shifting between different thoughts, emotions, and perceptual filters without much conscious control or direction. Consciousness technology would require awareness that is much more unified, focused, and deliberately directed. This would probably involve extensive practice in concentration, meditation, and other disciplines that train the mind to maintain stable attention and clear perception. But mental discipline alone wouldn't be sufficient. Consciousness development would also require emotional maturity, ethical development, and what we might call wisdom integration, the ability to understand and work with the deeper principles that govern reality and consciousness. Such development would be inherently holistic, involving not just the mind but the entire being, physical health, emotional balance, ethical clarity, and spiritual understanding would all be necessary components of consciousness that could interface directly with the creative forces of existence. This holistic approach helps explain why ancient traditions often combined practical techniques with philosophical understanding, ethical guidelines, and spiritual practices. The development of consciousness as a technology for influencing reality would require integration across all dimensions of human experience. The timeline for such development would probably be measured in years or decades rather than weeks or months. Achieving consciousness coherent enough to directly influence physical reality would require the kind of sustained, systematic practice that transforms not just mental habits, but the entire structure of awareness itself. But even preliminary development in these directions might begin to reveal capabilities and understanding that exceed our current limitations. As consciousness becomes more coherent and stable, we might naturally begin to experience forms of perception, intuition, and influence that provide glimpses of what fully developed consciousness technology might achieve. Such preliminary experiences might serve as both motivation and guidance for continued development, providing evidence that expanded capabilities are indeed possible and indicating the directions that lead toward their full realization. The development of consciousness technology also raises profound questions about the nature of individual and collective evolution. If consciousness can indeed influence reality directly, then the choices and development of individual awareness have implications that extend far beyond personal benefit. Each person who develops greater consciousness, coherence, and capability contributes to the overall field of awareness that influences the entire planet and all life upon it. Individual development becomes a form of service to collective evolution, and collective evolution supports and enhances individual development. This understanding might help explain why ancient civilizations that achieved consciousness technology appeared to work so harmoniously with natural systems. When consciousness develops to the point where it can directly influence reality, the arbitrary distinction between self and environment begins to dissolve. Advanced consciousness would naturally work for the benefit of all life because it would directly experience the interconnected nature of existence. Harming the environment or other beings would be experienced as harming oneself, while enhancing the well-being of the larger system would be experienced as enhancing one's own well-being. Such consciousness would automatically tend towards sustainability, harmony, and the enhancement of life, because these would be experienced as natural expressions of its own deepest nature and understanding. This perspective suggests that the apparent integration of ancient advanced civilizations with natural systems wasn't just a technological choice, but a natural consequence of development itself. As awareness evolves beyond the illusion of separation, it naturally begins to function in ways that support the well-being and evolution of the larger wholes of which it is part. But consciousness technology also implies capabilities that go far beyond environmental harmony. If awareness can indeed interface directly with the creative forces of reality, then sufficiently developed consciousness might be able to transcend many of the limitations that we currently consider absolute. Limitations of space and time, limitations of matter and energy, limitations of individual lifespan and capability, all of these might be transcendable by consciousness that has developed enough coherence and understanding to work directly with the fundamental principles that shape existence. This possibility connects to reports throughout history of individuals who achieved extraordinary capabilities through consciousness development, accounts of saints, sages, and accomplished practitioners who demonstrated abilities that seemed to transcend the normal laws of physics. While such reports are often dismissed as mythology or misinterpretation, they might represent authentic documentation of what becomes possible when consciousness develops beyond ordinary limitations. If so, these accounts might serve as roadmaps for rediscovering capabilities that represent the natural potential of sufficiently developed awareness. The investigation of consciousness technology also suggests new ways of thinking about death, continuity, and the ultimate nature of personal identity. If consciousness is indeed fundamental to reality, rather than just an emergent property of brain chemistry, then the development of consciousness might continue beyond the limitations of individual biological life. Ancient civilizations that achieved consciousness technology might not have disappeared in the conventional sense, but rather graduated to forms of existence that transcend the need for obvious physical presence. They might continue to exist and influence reality from levels of consciousness that are not bound by the normal limitations of space, time, and material form. This possibility would mean that contact with ancient wisdom and capability might be available not through archaeological discovery, but through our own development of consciousness, to the point where we can access the levels of reality where such intelligence continues to operate. From this perspective, the search for ancient civilizations becomes an exploration of our own ultimate potential, an investigation of what consciousness might be capable of achieving when it develops beyond the constraints of ordinary human experience. But this investigation also requires maintaining careful discernment between authentic possibility and wishful thinking. The desire to believe in extraordinary capabilities can easily lead to self-deception, fantasy, and the abandonment of critical thinking. Any serious exploration of consciousness technology would need to maintain rigorous standards for evidence and verification, while remaining open to possibilities that exceed current scientific paradigms. This balance between open-minded exploration and critical evaluation would be essential for distinguishing between genuine development and various forms of delusion or self-deception. The development of consciousness technology would also require understanding and working with principles that operate according to their own inherent logic rather than conventional human desires and expectations. Consciousness that could influence reality directly would need to be aligned with universal principles of harmony, wisdom, and ethical development. Attempting to use consciousness technology for narrow personal gain, power over others, or outcomes that conflict with the larger patterns of cosmic evolution would probably be self-defeating and potentially dangerous. The power to influence reality directly would come with built-in safeguards that prevent its misuse by consciousness that hasn't developed sufficient wisdom and ethical clarity. This natural limitation helps explain why consciousness technology hasn't been rediscovered accidentally or achieved by individuals primarily motivated by personal gain or power. The capabilities themselves require forms of development that automatically include the wisdom necessary for their responsible use. As we continue our exploration tonight, we find ourselves approaching questions that take us to the very heart of what reality itself might actually be. If consciousness can indeed influence physical reality directly, what does that tell us about the fundamental nature of existence? One possibility that emerges from our investigation is that what we call physical reality might be much more fluid and responsive to consciousness than our everyday experience suggests. The apparent solidity and independence of the material world might be largely a function of our limited perspective and undeveloped awareness. From the viewpoint of sufficiently developed consciousness, reality might be experienced more like a vast creative medium that responds directly to the quality and focus of awareness itself. Matter, energy, space, and time might be understood not as fixed constraints, but as flexible parameters that can be influenced and modified through appropriate consciousness development. This possibility connects to some of the most advanced theories in modern physics, which suggest that what we experience as material reality might actually be emergent properties of more fundamental information processing systems. If reality is indeed informational at its deepest level, then consciousness, which is intimately related to information processing, might have much more direct influence over physical phenomena than we currently recognize. But if reality is responsive to consciousness, then the development of awareness becomes not just a personal growth activity, but a fundamental responsibility for anyone who recognizes this relationship. Our consciousness doesn't just observe reality, it participates in creating it. Every thought, every emotion, every choice of attention contributes to the ongoing creation of the world we experience. This understanding transforms everyday consciousness development from an optional spiritual practice into an essential life skill. Learning to maintain clear, positive, constructive awareness becomes a form of environmental stewardship, a way of contributing to the creation of reality that supports life, growth, and positive evolution. Ancient civilizations that understood this relationship would have naturally developed educational systems, social structures, and cultural practices that supported the development of consciousness, capable of contributing positively to the ongoing creation of reality. Their entire civilization would have been organized around consciousness development as the fundamental technology for creating prosperity, harmony, and sustainable relationships with their environment. Instead of external machines and industrial processes, they would have used collective consciousness as their primary tool for manifesting whatever they needed. Such a civilization would naturally appear to be living in harmony with natural systems because their consciousness technology would work through the same creative principles that operate throughout nature. Their influence on the environment would be enhancing rather than destructive because their consciousness would be aligned with the patterns of intelligence that guide natural evolution and development. This possibility also helps explain why evidence of ancient advanced civilizations seems so elusive. A civilization based on consciousness technology wouldn't leave behind the kind of physical artifacts that conventional archaeology is designed to detect. Their technology would be embedded in the consciousness of their members rather than in external devices. Their infrastructure would consist of developed awareness rather than constructed facilities. Their manufacturing would be accomplished through consciousness rather than industrial processes. When such a civilization disappeared from obvious presence in the world, their technological capabilities would disappear with them, not because the technology was destroyed, but because it was inseparable from the consciousness that created and operated it. But this understanding also suggests that the technology of consciousness could be rediscovered and redeveloped by any civilization willing to invest in the systematic development of awareness. The capabilities aren't lost forever. They're available to any society that recognizes their importance and commits to the long-term cultivation of consciousness. Our own civilization might be in the early stages of this rediscovery. The growing interest in meditation, mindfulness, and consciousness research might represent the beginning of a species-wide recognition that awareness itself is the ultimate technology for creating sustainable, prosperous, and fulfilling life. But redeveloping consciousness technology would require fundamental changes in our priorities, values, and social organization. Instead of focusing primarily on external technological development, we would need to prioritize the systematic cultivation of human awareness and capability. This doesn't mean abandoning external technology, but rather integrating it with consciousness development in ways that enhance rather than replace the development of human potential. The goal would be to create symbiotic relationships between consciousness and external technology that amplify the capabilities of both. Such integration might represent the next stage of human evolution, a movement toward forms of civilization that combine the best aspects of consciousness technology with the best aspects of external technological development. The investigation of consciousness as a creative force in reality also raises profound questions about the nature of time and the relationship between past, present, and future. If consciousness can indeed influence reality directly, then the boundaries between different time periods might be much more permeable than our ordinary experience suggests. Developed consciousness might be able to access and influence not just present reality but past and future reality as well. This possibility would mean that ancient civilizations with consciousness technology might still be actively influencing our present development, working across time to support the evolution of consciousness and capability in younger civilizations. Similarly, our own consciousness development might have influences that extend backward and forward in time, contributing to the overall evolution of intelligence and awareness throughout the entire timeline of cosmic development. This understanding transforms the relationship between ancient and modern civilizations from a simple historical sequence into a complex, multidimensional collaboration across time. Ancient civilizations might be working with present and future civilizations in ways that transcend the normal limitations of temporal sequence. The search for evidence of ancient civilizations might therefore be simultaneously a search for understanding our own ultimate potential and a process of participating in the ongoing collaboration between consciousness across all time periods. But these possibilities also require careful consideration of their implications and limitations. If consciousness can indeed influence reality across time, then the responsibility for wise and ethical development becomes even more crucial. Consciousness that is developed enough to influence reality across time would need corresponding wisdom to ensure that such influences support, rather than interfere with the natural evolution of awareness and capability in all time periods. The apparent subtlety and hiddenness of ancient civilization influences might reflect precisely this kind of wisdom, the understanding that direct intervention could be harmful, while subtle support and guidance can enhance development without preventing the natural growth of understanding and capability. As we approach the deeper currents of night, these considerations bring us to perhaps the most profound question of all: what is the ultimate purpose or direction of consciousness evolution? If awareness can indeed develop to the point where it transcends individual limitations and influences reality directly, what is it evolving toward? One possibility that emerges from our exploration is that consciousness evolution might be moving toward the direct experience and expression of what we could call cosmic intelligence, the vast creative awareness that appears to guide the evolution of complexity, beauty, and understanding throughout the universe. From this perspective, individual consciousness development would be part of a larger process through which cosmic intelligence explores and expresses itself through countless forms of awareness and experience. Ancient civilizations that achieved consciousness technology might have realized their identity as expressions of cosmic intelligence and learned to function as conscious agents of universal evolution and development. Such realization would naturally lead to capabilities that transcend individual limitations because the consciousness would no longer be operating from the perspective of separate individual identity, but from the perspective of cosmic intelligence itself. This understanding would also explain why advanced consciousness appears to work so harmoniously with natural systems and universal principles. When consciousness realizes its identity as cosmic intelligence, it naturally functions in ways that support the evolution and well-being of all existence. The apparent disappearance of ancient advanced civilizations might reflect their graduation to functioning directly as cosmic intelligence rather than as separate civilizations with their own distinct identity and agenda. They might continue to exist and influence reality, but as expressions of universal awareness rather than as particular societies with localized presence and activity. Contact with such evolved intelligence might be possible, but it would probably require developing consciousness to the point where it could recognize and commune with cosmic intelligence directly rather than seeking contact with particular ancient civilizations. This perspective transforms the entire investigation of ancient civilizations into an exploration of our own ultimate identity and destiny. The question becomes not just whether advanced civilizations existed in the past, but whether we can develop consciousness to the point where we realize our own identity as expressions of cosmic intelligence. Such realization might represent the natural culmination of consciousness evolution, the point at which individual awareness recognizes its true nature as temporary expressions of universal consciousness exploring itself through infinite forms of experience and understanding. But this realization would also require releasing attachment to individual identity and personal agenda in favor of functioning as conscious agents of cosmic evolution and development. This transformation would represent a fundamental shift in identity and purpose that goes far beyond conventional personal development or spiritual growth. The willingness to undergo such transformation might be the ultimate prerequisite for accessing the capabilities and understanding that ancient advanced civilizations achieved. It might require not just developing consciousness but surrendering individual consciousness to the larger patterns of cosmic intelligence itself. Such surrender would not mean the elimination of individual awareness, but rather its integration into larger patterns of consciousness that operate on cosmic scales. Individual awareness would continue to exist, but as part of vast collaborative networks of intelligence rather than as separate independent entities. This possibility connects to mystical and spiritual traditions that speak of enlightenment, liberation, or union with divine consciousness. These traditions might preserve understanding of the same transformation that ancient advanced civilizations underwent when they developed consciousness technology to its ultimate levels. If so, then the practices and understandings preserved in these traditions might represent practical pathways for rediscovering not just consciousness technology, but the ultimate realization that consciousness technology makes possible. But such transformation would need to be approached with great wisdom and careful preparation. The shift from individual consciousness to cosmic consciousness would represent a fundamental change in identity and existence that could easily be misunderstood or misapproached. The development would need to happen gradually and naturally, supported by adequate understanding, ethical development, and integration with daily life and practical responsibility. As we drift toward the gentle conclusion of tonight's exploration, these considerations bring us to recognize that the investigation of ancient civilizations ultimately points toward the investigation of consciousness itself, its nature, its potential, and its ultimate destiny. Whether ancient advanced civilizations existed in the forms we've imagined or not, consciousness itself contains unlimited potential for development, understanding, and creative expression. We are not bound by the limitations of our current experience, but are capable of evolving toward levels of awareness and capability that we can barely imagine. The search for ancient wisdom becomes a search for understanding the wisdom that already exists within consciousness itself, waiting to be discovered through dedicated exploration and development. This recognition transforms the entire investigation from a historical curiosity into a practical exploration of human potential and cosmic destiny. The traces we seek in the past become reflections of the possibilities that exist within awareness itself, available to anyone willing to undertake the systematic development of consciousness. If you found yourself captivated by these profound explorations tonight, if these questions about consciousness, reality, and human potential resonate with something deep within your own awareness, I'd be deeply grateful if you could take a moment to hit that like button. Your engagement helps us continue creating content that explores the deepest mysteries of existence with the respect and wonder they deserve. And if you haven't already, please consider subscribing to Simply About Earth. We're building a community of minds that refuse to accept surface-level explanations and instead choose to dive into the infinite depths of what's possible. In this way, the exploration of ancient possibilities becomes an invitation to explore our own future potential, to develop the consciousness and understanding that would allow us to achieve whatever levels of advancement might have been reached by civilizations from the past. Whether those civilizations existed or not, the capabilities and understanding they represent remain available to consciousness itself. The question is not whether such development is possible, but whether we are willing to undertake the patient, systematic cultivation of awareness that such development requires. As you prepare for sleep tonight, let this understanding settle gently into your awareness. You are not just an observer of these vast mysteries, but a participant in the ongoing evolution of consciousness itself. Your capacity for wonder, your willingness to explore profound questions, your openness to extraordinary possibilities, these are expressions of consciousness exploring its own infinite potential through your unique perspective and experience. Rest tonight knowing that you carry within your own awareness all the potential that we've explored together. The same consciousness that might have expressed itself through ancient civilizations is expressing itself through you right now, investigating its own nature and potential through your questions, your exploration, and your development. Sleep deeply, dream wonderfully, and wake tomorrow with renewed dedication to the development of consciousness itself. The greatest discoveries aren't hidden in the past. They're waiting to be uncovered within the infinite depths of your own awareness, available to be explored and developed through the systematic cultivation of consciousness. Sweet dreams, fellow explorers of the infinite potential of awareness itself.